So good morning, Karthik.
Good morning, Bhishma.
We are good to go, Karthik.
Good morning, everyone. Bhishma, am I audible?
Yes, yes.
Good morning, everyone. Thank you so much for joining us on our Automotive Virtual Tech Day. Bhishma, can you present the screen?
Yes, Karthik, I will. Just a minute.
Bhishma?
Yes, Karthik, I am doing this. Yes,
Thank
Karthik.
you. Good morning once again to each and everyone who have taken the time off to join this Automotive Virtual Tech Day. Thank you so much for sparing your precious time and joining us. And I welcome you all on behalf of ANCIT Consulting to our second Automotive Virtual Tech Day. All right. So the objective of this conference, I would like to put it into three folds. First is our objective at ANCIT has always been to build a very strong automotive community, and we do regular conferences every quarter, and this is our second virtual tech day conference for this quarter. And on also to help the community, what we also do is every month on the first Thursday, we do a session on AutoSAR on various topics of AutoSAR based on requests from our friends and from our community. We do a lot of sessions, and we also have an active LinkedIn community on AutoSAR. So this is something that we try to do every quarterly, monthly basis in order to make sure that we help to build a very strong automotive community in India and abroad. And this is one of our initiatives. And once again, I welcome you all for joining this wonderful virtual tech day session. And today we have some very extraordinary and special speakers in our midst who will be talking about various topics which are pretty interesting, exciting, as well as new to the automotive industry. So we have a team from ST microcontrollers who will be talking about their development kit and how it can help in the automotive industry, and how it actually helps a lot of startups and a lot of new ventures which have propped up into the automotive industry. So that is something we are all excited to hear about. And today we also have the chairman of the AUTOSAR Consortium, who is here to speak about AutoSAR and its future. We have a good friend Eswaraiah, who's going to talk about cybersecurity, topic which is gaining momentum of late with the latest technologies being advanced in the car. And we also have a team from EB Tresos, and we also have someone talking from Skillicon, Mr. Nirmal Kumar, who will be talking about the diagnostics. So we have a lot of interesting sessions queued up. We are going to start with the first session. And the first team that's going to talk about is from ST Microelectronics. We have Alessandro Troisi, Daniele Marino, and we also have Max Vizzini, the team from ST Microcontrollers, who are going to take a session on automotive development kit of ST Microelectronics. Daniele Marino is a senior automotive software architect in the automotive discrete groups of ST Microelectronics. He's also manager of the automotive development tool development team. If you look at what is this automotive development kit, the automotive development kit is actually a kit which builds various. This team actually builds various applications using the ST Microelectronics automotive development kit. They build a lot of ECUs, and these applications are actually published. The MCAL is published, and users, the prototype is actually ready. So the users can actually take this, I will call the MCAL, they can take the application and start using from them and actually customize it just to their application. So it's a rock solid platform that is already built, and it actually reduces the time for application engineers in order to build their ECU. And many startups, many young automotive companies who are emerging into the market are using this ST Microelectronics Auto Development Kit to build their electronic control units. So before I talk too much about it, I would leave it to the team. And Marino and his team, Daniel Marino and his team, are responsible for this auto development discovery board and writing the functional board drivers for this kit. Marino himself is a computer science graduate from the University of Catania, Italy. And thank you, Marino, and your team for joining us from ST Microelectronics. We are really looking forward to hear you, and also we look forward to experience your automotive development kit. Thank you so much again for joining us, and over to you.
Thank you for the presentation. Okay, let me share. Hello, everybody. My name is Daniele Marino. I'm a software engineer senior manager. I have been working in ST Microelectronics for 22 years. Welcome to AutoDevKit session. The agenda of this session: AutoDevKit motivational, SPCify Studio deep dive, AutoDevKit hardware deep dive, and model-based design approach with AutoDevKit. The future and present of the automobile market has new megatrends: electrified, autonomous, shared, connected, and yearly updated. The mobility of the future will be much easier, more flexible, and more individual for users. The car of the future will be used and shared. AutoDevKit enables a new industrial approach for ECU development. The AutoDevKit plugin for Eclipse extend SPCify Studio into a strength-forward, low-cost, time-saving tools designed to help automotive application engineering evaluate, prototype, develop, and deploy complex embedded systems. The main advance of AutoDevKit initiative are prototyping, with the integrated hardware and software components, component compatibility checking, and MCU and peripherals configuration tools. Reuse, the same code for different MCU. Flexibility, allowing the creation of a new system solution from existing solution by adding dedicated board for further functionality or removing a user board. Simplification. AutoDevKit provide a set function APIs able to control specific function board. The APIs contains function able to exploit the chosen hardware functionality and facilitate the communication with the MCU. Time to market. Why is AutoDevKit unique on the market? Integrate environment with various of models available. Rapid prototype of idea. There are no limits on the modules to be connected. There are no connectors limits. The hardware can be reused. Each module is well encapsulated from the hardware point of view and software. It's a common platform. So once learned, it can be used for all functional board without having to learn new software. New GUI or new hardware every time. The system is open. Thanks to Eclipse technology, it's possible to integrate the new software. What is the relationship of a specified microcontroller and the AutoDevKit? The specified MCU are very valid for the prototyping phase. Excellent if you decide to go from a prototype to production, but above all, through AutoDevKit, it's possible to make the MCU application independent. What is AutoDevKit possible user profile? The user profile is a product engineer evaluation. I can use AutoDevKit to evaluate the functionality a single product, and thanks to existing toolset, I can know and implement simple and complex operation. System R&D engineer. I can build a complex system or subsystem. Once the evaluation is completed, I can choose to use the prototype hardware and software or build a final version. Development engineer. I use SPC5 and SPC5 Studio for my product development. The rules can be covered even by the same person in different moments of the design cycle. This is very important. SPC5 Studio Deep Dive. SPC5 Studio, SPC5 environment is split into part. Hardware support, we have multi-core power architecture technology, I/O peripherals, safety, SLB, SLC, security, HSM, and Evita Medium. Software support, Eclipse, the SPC5 Studio is built on Eclipse. Code generation, MCU abstraction layer, PMAP editor, MCU visual configuration. Inside of the SPC5 Studio, we have the opportunity to use the GUI pins visual configuration, clock tree visual configuration, peripherals visual configuration, power consumption visual configuration, and general time unit. This is help the user to configure the micro for your application. SPC5 Studio is built on Eclipse, plugin development environment that user to define a new component. It's provide a comprehensive framework to design, build, and deploy embedded application for SPC5 power architecture, 32-bit microcontrollers. The code generated by SPC5 Studio is ANCIT compliant and Mr. Standard quality fully compliant. For your basic project in SPC5 Studio, you must have these are component. Platform is the main component and it's contained the configuration settings of selected MCU. Init package is a component that contains board initialization, clock tree, operating system abstraction layer, and interrupt request queue settings. And low-level drivers. There are the MCU peripheral drivers written in ANCIT code. All component settings will be stored in a configuration XML file that represent the SPC5 Studio database project. AutoDevKit technology, it extends SPC5 Studio with the 4 technology: automatic pin allocation, a functional board graphic configuration, and board view, and abstract component drivers and users APIs. Create an automotive application does not mean only to write firmware for a chosen microcontroller, but it's much more. To create an automotive application, the first step is to know which hardware modules compliant with the system requirements are available in the market. Start from system requirements analysis. The engineer will choose a microcontroller architecture and the evaluation board accordingly to power computational and memory resource needed. For example, it could be chosen from the AutoDevKit MCU board list. This will be shown in the next slide. A course 4M or 1M according to the flash memory size that we need. In the second step, the engineer will choose in the second step, the engineer will choose all functionality board according to the application requirements. Following AutoDevKit will configure the MCU peripheral and will allocate each pins of functional board selected. For example, it could be chosen from the AutoDevKit functional board and a DC motor driver based on VNH, because I want to create a wiper ECU. In this case, AutoDevKit will allocate automatically GPIO and timer peripherals in order to drive our DC motor in both directions via pulse width modulation. After automatic allocation of pins, the engineer will perform a manual connection between MCU evaluation board and the functional board in the easiest way by using board view as guidance. AutoDevKit is ready to decode generation of all function boards APIs. APIs are level function that will perform some software calls to specify studio low-level drivers. For example, I'm able to move the DC motor with a specific rotation speed by using a simple API called the set motor speed. The function we call a low-level driver function that is able to drive the timer peripherals, configuring the duty cycle of the PWM square wave. After computational and linking, compilation, and linking, your application is ready to download in the flash memory of the MCU. AutoDevKit hardware deep dive. AutoDevKit Explorer is an plugin available in the desktop version, web application, and mobile phone app, iOS or Android. The AutoDevKit Explorer helps you navigate and access to your comprehensive range of hardware and software resources in the AutoDevKit ecosystem. You can select the AutoDevKit components for your application of the state interested and process it to generate the specified Studio IDE project, which can be sent to you by email. There is also an option to receive a separate email with a shopping cart for the hardware components requirement for your project. AutoDevKit boards types could be grouped on 3 classes: MCU boards, connector boards, functional boards. MCU boards are evaluation board with the automotive grade microcontroller. ST offers a wide portfolio of microcontrollers for automotive application, including the 32-bit specified family built on power architecture technology. There are single and multi-core solutions that support not only the last automotive transportation areas, such as electromobility, gateway, and ADAS application, but also bring innovation to existing applications, such as body, powertrain, chassis, and safety. Connector boards allow the user to connect functionality boards to the MCU boards. There are 2 kinds of connector boards: dedicated and generic. Dedicated connector boards have been developed for a specific application. It's allow a simplified connection between the MCU functional board with a fixed in-pin assignment. Instead of generic boards are more flexible for prototyping phase because thanks to not fixed MCU pin assigned, they allow the user to perform a pin configuration in order to address all function board requirements. This is the number of the AutoDevKit ecosystem in the last release 1.7.0. We have 75 boards, 45 additional products, 21 firmware drivers, 68 core products. We have another tools, the tutorial available on the YouTube. We have 15 videos, 38 examples, and 8 demonstration kit. The hardware board summary is split in MCU discovery boards, motor control boards, power and light boards, audio boards, sensor boards, interface boards, communication board, and actuator boards. The MCU discovery is split for the memory of the sites of memory. We have the light version without the connector. We have the full version with the all connector, the Ethernet connection, or the DB9 connector for the CAN communication. This is a 4M megabyte. This is a similar type, but in this case we have only 2 mega. And we have another version of the evaluation board, like to STM32 Nucleo. This is available in 2M and in 1M. Motor control function. We have a stepper motor driver, dual DC in 2 versions. Single H bridge, you can drive the DC motor, the BLC control driver, and the automotive front door device. Power conversion and lights boards. We have the LED drivers, the 100 watt DC-DC, and we have another version with 2 channel 27 watt DC-DC and the DC-DC voltage regulator for automotive with automotive grade, and adaptive front lighting adapter for specific application. Audio boards, the audio boards family is a very compact EVAS solution available with or without MCU. This device is Class D audio amplifier that emits warning sounds to alert pedestrians of the presence of the vehicles. This is available in 3 formats. The sensor boards. Time of flight, this is an industrial grade. We have the two sensor board with 2 sensor third party, the Hall sensor and the LiDAR sensor. And we have the MEM sensor in automotive grade, motion sensor, 3D accelerometer and 3D gyroscope, inclinometer, 3-axis digital accelerometer. Interface board. We have the dual USB Type-C general connector to plug on the evaluation board MCU 4M, blind spot for specific connection, and the LSD touch board. Communication board, the Bluetooth network processor and the GNSS positioning our board are in industrial grade. The NFC reader is in the automotive grade. The actuator functional board, we have a single eyesight driver. This is a switch in dual mode or in quad eyesight driver mode. These are the automotive solutions that we have been able to reproduce thanks to AutoDevKit. This is the adaptive for lighting solution, the blind spot detection and warning educational. This is an educational kit, how to use the AutoDevKit software. AVAS system for electric vehicles, trunk system, and iCar. The trunk control system. The first goal is to offer an innovative approach respect to solution currently used in the car. This approach provides to use to time of flight sensor on the bumper. This is this box is represent the bumper, the car. This leads to open or close the trunk by means of a gesture. For this purpose, we shall implement a foot detection based on a specific sequence of movements. Another goal is to offer a redundancy mechanism for trunk opening or closing. For this purpose, the system will be developed allowing control through the most common communication technology, such as NFC or Bluetooth Low Energy. In addition, the system design included the safety and security mechanism. These concepts are important and have to be present in modern automotive compliant design. For safety purpose, the goal is to prevent damage to people near the car and the trunk itself. The safety mechanism consists in acoustic and visual signaling to alert the start of the actuation, opening or closing, and in preventing actuation if car is moving. Another important concept is to have a mechanism stop the trunk movement in case of a jam is detected in the opening or closing phases. This is the board used inside of this demo. i.e. car. The system hosts in a 4M microcontroller able to acquire discrete acceleration variation on 3-axis reference system. The initial data are retrieved by the motion sensor. The acquired data is passed to a long short-term memory, recurrent neural network, able to classify the car state. The results of the classification is present on the LSD touch display. Car state classification: car parked, car driving on normal condition road, car driving on a bumpy road, car skidding. Adaptive flow-like solution is based on a technology installed on a car that allows the driver to change automatically the direction of headlights according to the road layout. In this demo, I used the 4M daily drivers to drive the single headlight and the stepper motor to follow the direction of the steering wheel. And we have the single channel eyesight driver to switch on off the fan inside of the headlight. EVAS solution, an acoustic vehicle alerting system, is designed to emit vehicle warning sounds and alert pedestrian to presence of the electric driver vehicles. Model-based design with AutoDevKit. Model-based design main goals is to ensure that the final product meets customer needs and requirements to a rigorous design and testing process. It's not the need to wait until the system is built to test it. Develop and test the tasks are performed in parallel through the entire process. We estimate that a defect discovered after product release it costs up to 10 times more to fix than defect discovered during the requirement phase. By applying a rigorous validation process at each phases of the development process, you can drastically reduce the cost of the simulation techniques are employed for verification, model in the loop, software in the loop, hardware in the loop, and rapid prototyping. Automatic code generation is another great benefit of using models. It's saved cost and development time, and it's improved quality. Therefore, you can implement in the flow seen before, and generate the code through the MATLAB and integrate the generated code within your project in SPC5 Studio. Then you can follow this flow. Is the same show in the previous slide. In this slide, you can find the useful link on AutoDevKit. For example, the community, the AutoDevKit plugin, the user manual, and the video on the AutoDevKit. We have also the tutorial to explain how to use AutoDevKit inside of the SPC5 Studio. And we have also the video demonstration to explain how to create the demo for Automotive. Thank you for the presentation. Any question?
I think there is no question. Karthik, we are not able to hear you clearly, Karthik.
Daniel, can you hear me?
Yeah,
Hello?
yeah.
So my question was, in the demonstration, we had a few prototypes that were being demonstrated. They draw the same current as per the actual car.
Yes, all the products demonstrated are products that are actually employed in cars. So we are just using the same products that are sold to car makers to build all the boards that you have seen with AutoDevKit.
Okay. Thank you.
You're welcome. Is there any other question?
No, Max, there are no more questions.
Okay, then we would like to thank you for hosting us and see you next time, next chance. Thank you to everybody for your attendance.
Thank you.
Okay.
Thank you, Daniel. Thank you, Max. Thank you so much for joining us and giving us a quick introduction about what the auto development can do. And you also had a chance to experience the kind of applications that are already built and how we can start the automotive. Appreciate it.
Thank you. Bye.
Gentlemen, our next session will start exactly at 11 o'clock. So take a quick break. We'll join. Let's stay connected. Start the next session.
choice. But I certainly got a view. So that's one of the reasons why everybody as well. So, thank you so much for holding on for a couple of minutes and start Asmus, Rinat Asmus.
Hello. Hello. Hi, hello.
Hello.
Yes, Karthik. We are still waiting for Rinat.
Okay. Hold on. Couple of minutes. Proper.
Karthik, your voice is breaking, Karthik.
Hello.
Yeah, Karthik.
Can you just drop him an email?
Yeah, I already dropped him a mail.
Sure. Okay. We'll just hold on for a couple of minutes. You should join anytime.
Hey guys, Malay here. Just give us a couple of minutes. We're trying to reach Rinat as it's early morning there. Some issues in getting connected with him. Just give us a few minutes, yeah? Thank you. Thanks for understanding.
Yes, thanks for holding on. We are yet to receive a call from Rinat. We're just waiting for him. We'll keep you posted in a couple of minutes. Hello. Hey, I regret the inconvenience. Somehow we are not able to reach Rinat. It's around 4 o'clock in Germany, and I'm not very sure what happened. We are not able to reach out to him. But as part of our knowledge sharing session, what we would like to do now is we would like to present to you a small training video on how to do unit testing. We will run you through for the next 45 minutes so that we don't lose out on the time that we have prepared. So we will share that with you, and at 12 o'clock we will join you again for the next session on security. We are very sorry for the inconvenience. We are not able to actually reach out to Rinat and find out what happened. Thank you. Bhishma, can you present the unit testing presentation? Bhishma?
Just 1 minute, Karthik. I'm doing that.
Thanks.
So yeah, we got like quite a number of feedbacks. So as I know, like we have a mixture of people. We have experienced people, plus we have someone who is beginning into the unit testing to get to know about unit testing. So how we will be like laying out is like we'll start from the very scratch. So you will get the beginning as well. Plus, like we'll move on, like we'll keep on increasing the complexities. So by these 4 hours, like we'll reach up to that params and all those things we'll cover mock, and we'll show you code coverage and all those things. So it will give a whole good picture to start with. So if you wanted to implement a unit testing by yourself, Saravanan mentioned, like if you have certain exclusive doubts, like we'll try to cover it up. Okay, so that's great. So, and during the session, if you have any doubts, you can just stop me then and there, and you can ask me. So that will be the way. And as I mentioned before, this will be both interactive sessions. Like so, you will be also working parallelly. You'll be also trying on your pieces parallelly, so which will give you good grip on this whatever we are doing. And then we'll break in between, and we'll see like you are able to understand it, you are able to like to digest it, and if you have any difficulties, we can try to resolve it. So that's it. Okay, great. So here, so now just to begin with, so what's your understanding on unit testing? What's unit testing? So we'll just start our discussion from there. So what is have you ever worked like as I know, like there are few people like worked on unit testing. So can someone come up with a like a small description for unit testing associated with the Google test is different, or who does the unit testing? So there are 2 ways. One is that we needed to write a main function which calls their Google test all the time.
Unit test is a small, we are going to test a small part of a code, like a basic blocks.
So you can keep this -L G test. Let me close this. I'm closing this function. Yeah. Okay. So I'm keeping only here.
Yeah. So basically, unit testing means one unit, like one file we have to test, like one unit only, individual functions. So other functionality we will stops other than the definition is not available in the same file, and we have to verify whatever the initialize the values in the in the implementation. So based on that only we have to verify that okay, this functionality is working fine or not. If any mismatch between the functionality and the implementation or design document, so we have to like verify the all the software regarding the unit wise. So that is a unit testing.
Perfect. Yeah, that's great. So that's a good explanation. So it is just covering like all the areas. So as you mentioned, like the unit testing is about testing a piece of code or a function or maybe one method. So you have one small unit part and you wanted to test it on your code. So that's what all about unit testing. And as you mentioned, like yes, we have certain preconditions and we should have certain condition we are expecting, we will be expecting certain results out of that particular unit function. So these things like we need to evaluate whether that particular function is properly working as we expected. So that's what the testing will do. So it will be a single function or a single unit inside a code. So we'll be testing single unit or smallest unit in the code through unit testing. So if I take types of testing, we have these many testing on a major node. So we have unit testing that will be performed by the developer. That will be, as we discussed now, it will be for a single unit inside a file, or maybe inside a file, like you have number of functions, so you are testing individual functions. So this will be the unit testing. This will be the first part, and you will have an integration testing, whereas like you will collect number of functionalities or number of files, you will integrate it together, you will create a software, and you will test that particular part of software. That kind of a functionality testing or integration testing and all those things. Then you will have a system testing. It's the third level of testing, which is like done by actual testers. So there, like you will get the complete system ready. Like you will have all your modules integrated with it, and you will be testing the complete system, the complete functionalities, not only a part of package or a part of functionality, but it's a complete functionality you're going to test. And then the last one is user acceptance test. So there, like we will go for customer testing, like on like we'll deploy our software into the target machine, maybe on the car we'll deploy, and then we'll test it. So likewise, so we're gonna do a user acceptance test at the fourth level. So in small scale companies, what happens, like they'll not do this first and second one. They'll directly jump to the system testing. They'll write the code. Maybe the developer will see to the code, but they'll not test anything. They'll not have any backed up document to say that, okay, I have tested my software. Rather, they'll directly go to the system testing. They'll implement everything, and they'll try to evaluate, okay, whether system is working properly or not. If something goes, then they'll go back and debug and correct it and come back. So that will be the way. But in industries like automotive and avionics and all those things, so it must be very standardized flow. So they will do testing for each and every line of whatever the developer had written, and they should have a document backed up with it saying that, okay, this is being tested and robust. So like, so that's where like unit testing comes into the picture, and then integration testing, like this is the flow. So here our scope of discussion today is like this one, unit testing. So here, this is like one small representation I saw, like here, one single file, maybe many file, like main file, init file, and all those things. So one single file, inside that single file, we are going for testing for maybe like one small function, one small method, and all those things. So that's unit testing. If you have number of functions, like if you are taking a package and you are testing it, that's integration testing. Then you are doing it completely for the complete packages, then it's functional testing or maybe system testing. So this is like a quick intro about the types of testing. Okay, so now let's discuss, okay, what you guys do, like whenever you wanted to test. Maybe what you will be doing, like in your softwares so far, whenever you are writing some softwares, maybe in embedded or maybe like other platforms. So what we generally do? Any comments on this?
Can you come again? Hello?
Yeah, like what we used to do, like if we don't have a unit testing, so what we used to do to actually test it, the softwares, like if it's working properly.
Some debuggers, like
system test.
Yeah, okay. Yeah, what someone said, some debuggers, someone said, okay, system testing. So we use, okay. Yeah, so
module test or functionality test, we will change the unit testing. Like if any functionality we are not able to test in the unit testing, then we will go for the system testing.
Okay. So it's on a higher end. So like, okay, in a single file, what we'll do is like, okay, so I have written my software, I have a piece of code, and I wanted to test it. So like either, as we said before, like it will directly go to, instead of we'll neglect this unit testing and all those things, we'll directly deploy our code into the system. We'll like push our code into the repository and they'll test it in the system level. So that's one way. The other way, if you wanted to test it, then we might be using print statements. Like we might, I'm speaking about, okay, I don't have a unit testing frameworks. Rather, I wanted to test my software, my code, whatever I have written. So at that particular point of time, we might be using print statements. Like we would have written like to test, okay, whether my value is coming properly. I would have put some print statements, right? Like we would have been done long time. So I'll put printf and just check whether value is coming out, like whether the expected value is there. Or like we would have used, someone said, like we would have put debug points and see that, okay, whether it is hitting my function, or my like control is going inside that particular switch case, or so and so. Like, so I wanted to test it, so we may put that debugging points, or like, as I said, manual testing of the functions. Like I'll put all my inputs, I'll just see whether my LED is glowing, I'll test my motor is running properly, or like whether the proper value is coming out, the proper data is throwing out of the CAN bus. So these kind of functional level testings we'll do, or like developer testings, like same thing, like you put GUI and all those things, so you're gonna test it with that. So, but the problem is, you have these things, but they're having all of them, all of these methods having their own pros and cons. So if you use print statements, then it's like a bad coding practice. It's not, you can't put your print statements inside the actual code, whichever you're going to deliver, because like that piece of code should not be there in the actual code. You can keep it, but once you're done with the testing, you should remove it. So it will be very limited for us. So if you wanted to test the same software in the later stage after you pushed it, then again you need to write all your print statements, because you can't push your code with the print statements into the deliverable. So that's one limitation. And like it's so messy. Like you will have, you may know, you would have written certain print statement somewhere, and then another developer who's going to look into the code will not get the idea, okay, why you have actually put the print statement there, what was the necessity, like are you using for some debugging purpose, or are you using for something else, where that value is coming from. So they'll have like some clumsy idea about it. Plus it will be a little messy, and you'll not be able to do a later stage testing. So that's one limitations in the print statement. And if you say the debugger, it's again the same thing. Like debugging points and all those things, you're going to keep in your PC, like in your environment, in your IDE, you're going to keep all the debugging points. But the code, whatever you are pushing, will not have the information about, okay, where are all like the debugging points were kept, and what is the debugging environment you set, what are all the watch variables you keep. So you don't know that environment. So that environment is limited to your PC. So it can't be like whenever you push the code and later someone wanted to test it, they wanted to again set up all these environment, the debugging environment, so that they can test it. So it's like having its own limitations. And functional testing, yes, it is fine, but the problem is there is a possibility of missing. You may test it by yourself, but there is a possibility of missing certain points. Like you may miss to test certain functionality, or you may miss to certain conditions. Like you will have maybe like 4 combination of conditions. You may test the 3 conditions and you may miss to test one other condition, so you're going to lose certain part of it, and you don't have the track of it. That's one the other problem. Like you can say that, okay, I have tested it, but you can't prove that. You can't share some documents in saying that, okay, I have tested so and so and so on this functionality. So you don't have any backups. So that will be the problem. So these are all the problems. So these are all the conventional ways we're going to use for testing. If I have a code with me and I wanted to test it, these are all the conventional ways we're going to follow, but they have their own problems. So then they are coming with the concept of unit testing. So you want some very standardized framework where you can test it, and you should be getting some document, the proper results out of it, saying that, okay, this you can use it for, I can, okay, and you do your action. Maybe you call your function. Okay, fine. So what I'll do, let me say int add A comma in B. I'm just writing some small stub of code, or maybe I'll not put this as well. Void. Okay, so I will have int A is equal to 10. Fine. Int equal to 20. This is my arrangement. So here I'll say result equal to A plus B. This is what I want to do, and then here I wanted to do a check saying if result equals or maybe like 30. I'm expecting this. Fine. So this is what the three statements. Like first one is I'm arranging whatever I needed for my conditions to check. So I'm arranging int A is equal to 10 and int B is equal to 20. Then here this is where I'm acting. This is my act. I'm calling my function or I'm doing my logic. Then here this is my assert. This is my assert. Here I am checking. So this will give maybe like this is not like pass or fail. This is going to give me whether this whatever the result loaded is 30. If it is 30, yes, it will give pass. If it is something else, it will fail. So this is what the basic idea about like. So this will not be int main. This will be test and all those things. Yeah.
Sorry for interrupt.
Yeah.
Hello.
Yes.
Are you presenting your screen? Are you sharing your screen?
Yes. You're not seeing.
I'm not able to see. Anyone other person able to see? Hello.
Yes.
Yes,
it's visible to us.
Okay.
Maybe you can do one thing. You can just log out and come back. Maybe some network troubles.
Okay, you can continue. Yeah, no problem.
Yeah, please. Yes. You just let me know still if you're not able to see. Like I'll stop the sharing and restart it again. Okay, cool.
Okay.
So yeah, so this is what the basic idea about arrangements, act and assert. So yeah, any doubts till now? Like we'll just break for some 1 minute, 2 minutes, and we'll just try to digest what happens, and then we'll try to go into the hands-on as well. So you have any doubts so far whatever we discussed?
Yeah, here where is the check function?
No.
Hello.
This is for unit test or developer test purpose.
Hello. Is my voice is audible?
Yes, you are audible. I think the presenter is not audible.
Yeah, not there, right? Yes. Yeah.
Discuss about like, okay, I'll just discuss one more thing here. Okay, fine. The unit testing frameworks available. So we'll just discuss this and then we'll jump into our hands-on sessions. Okay. So now, okay, you have came to know that okay, we needed some unit testing. So we will write something like this. We'll write something like this on our test case, and they'll give you report saying that okay, this testing has failed and this testing has false and all those things. So these are all the few unit testing frameworks available. So if you want to do a unit testing, you need a separate framework. Uh, so if you are writing a C CPP code, you wanted a framework to write your C CPP unit testing. If you're writing for Java codes, like you want certain Java frameworks where you can write your unit testing for that. So likewise, so there should be some frameworks you're going to use, you needed to use to implement this testing so that it will run these test cases, they'll generate the reports and all those things. So and so, like there are a number of things. So those things will be done. So one is like Java had introduced unit testing concept. So this JUnit is so popular in Java. So this is an open source again, like Java unit testing. This is one framework. And for Python, there is py unit. So this is like for Python unit testing. So if you wanted to test any Python codes and all those things for unit testing, we can use pyunit. And there is some Google test which is for CPP, which is built on top of CPP. But yes, we can use it for C as well. So we can use on C, CPP and all those things. So this is from Google. So nowadays, like most of the industry is trying to move to Google testing because like it's free and it is having lot of integration with different IDEs like Visual Studio, Eclipse and all those things. So many of the industries are trying to move to the Google testing. And other commercial features, these are all like kind of open source and all those things, but there are commercial testing tools. One is Cantata. Yes, we would have been using Cantata in like if you're in Bosch and all those things, like you will be using Cantata. And there is one RTRT tool from IBM and another tool from Vectorcast. From the Vector, there's a Vectorcast. So there are number of other commercial and paid testing tools as well. So we can use like we're going to be using Google testing in our like sessions. Like we'll be having all our hands on this thing because like nowadays like most of the guys are trying to move to Google testing. So but and one other thing, like if you have the understanding of how the Google testing has been structured, it's very similar to Cantata. So we have worked on Cantata and the Google testing. So it's almost all similar. Like the terminologies will be little different, but the way of using and how it's being implemented, those are all like almost similar. So if you have a hands-on grip in any of the tools, like it is like migratable to other tools as well. So that's what the idea. Now, so there are environments where we can test. One is that, as I said, we can integrate our Google test in Visual Studio and we can see, okay, how this been done. Or we have Eclipse plugins available, so you can integrate your Google test into the Eclipse environment and you can do it. So but currently for our easy doing, like we are actually going to work with some online compilers. So we have an online compiler. So we have online compiler. So with this online compiler, we can implement the same thing. So like to make it easy, the training to be like so straightforward. Like otherwise, like there will be a lot of complications of installing softwares and all those things. So we just it's all similar. Like we're gonna write all our conditions over here, and we can see it. We'll show you like in how it is in Visual Studio, but we can try it out over here. So that's the basic idea. So we'll be using this Go Bolt. I'll just put it on chat so you can also like start working with it. This we are in Zoom, right? Where is the chat? Languages. So we're gonna start with CPP because our Google test framework is on top of CPP. So we'll use CPP here. This first thing to do. Yeah.
Everyone is able to follow, right? Did you guys got this option?
Google test?
Here.
Yes.
Fine. Okay. The second thing you wanted to do is like here, which compiler. So you wanted to choose the 10.2 because like Google test supports on 10.2. So you wanted to choose, like you can scroll it down, like you can choose 10.2, 8664 GCC 10.2. Is that happening? Done?
Yes.
Okay. So there, whenever you open, you will be already got some in the square or something. Yeah. So you will, okay. We'll just write a small hello world to test whether the compiler is working properly. So I'll put hash include IO stream. Okay. And then I'll put void main, void.
Hi, excuse me.
Can you hear me? Okay, I'll just put standard cout. Hello.
Yeah, hello.
Okay. Okay. So I'm just putting some hello world. Yeah. And we wanted to see the output, right? So to see the output, there is something called add new over here. So in the add new, we can see executor from this. So you can click on executor from this. So you will be able to see some execution window. So there you can see hello world. So this is a output command prompt or output line, output space. So yeah, please try this. Just a function. So whatever I wanted to write a test case for this. So that's the basic idea, right? So okay, now one or two things to add on here to enable your Google test is that first one, we should be including this G test. So I should say include G test / G test.h. So I'm trying to include it. So whenever I try to include, I'm getting an error saying that, okay, fatal error, no such file or directory. I can't find this library. Just saying this compiler is saying, I can't find this particular directory. So I wanted to say to this particular compiler, okay, you wanted to go and add this particular G test. So for that, here there is a method, include libraries. So you can see like in both the sides, here is also include libraries, here is also include libraries. So we wanted to add our Google test library into both the environments. So here I'm going to click over here. I'll get a window saying libraries. I'll type Google test. So here I got some Google test. I'll say 1.10. So it is got added. I closed it. Now here also I am going include Google test. Here I got it. Google test. I just added it. So here 1.10 both. So now it's bingo. So now they are saying, Okay, undefined reference to main. There is no main. That's what the problem. But the previous issue was resolved. So this is done.
Hello.
Yes.
Yes. Can you repeat this?
Yes, sure. So the idea, whatever I did was like I wanted to include my GTest library into my environment so I can use it. So I'm just clicking over here. There is a button here saying library. So I'll just click over here, and in the top search window, I'll search for Google test. Here I can choose what version. So I'll choose 1.10. So it will get added. So this is a routine I wanted to do. So likewise, I wanted to add it over here as well. So here also, like I have my library to add it. So on the both places, like this is the compiler, this is the execution area where
Hello, Rinat. Thanks for joining, Rinat.
Hello, can you hear me?
Yeah, I can hear you.
Great, great.
Hey, Rinat.
Hey, everyone. Hey, it's Rinat speaking. How are you doing?
We are doing good, Rinat. Hi, Rinat. This is Karthik, the host. Give me a couple of minutes. I'll just introduce you to the forum before we kick started. Yeah. So, hi, Rinat. Good morning once again, and thank you so much for joining us. A quick introduction about Rinat. Rinat Asmus is the chairman of the AUTOSAR Consortium, a word which has taken the whole automotive industry by buzz. The word big buzzword is AUTOSAR. So he's chairman of the AUTOSAR Consortium, and he's an active AUTOSAR steering committee member representing BMW in the AUTOSAR forum. Rinat Asmus has around 12 years of experience working with AUTOSAR. He has a master's degree in robotics and automation engineering from the University of Applied Science in Würzburg, Schweinfurt. And he joined BMW in 2009. And since then, he's engaged as a software architect, engineer, and also as an application engineer in BMW EC projects. So that's a quick background about BMW as an engineer. And Rinat Asmus is also passionately committed to further development of AUTOSAR as an organization. He's taken over as the chairman of the AUTOSAR Consortium in 2022, and he's now actively driving the whole community as well as the organization towards new heights. Thank you so much for joining us, Rinat, and we look forward to hear from you.
Thank you very much. So it's my pleasure today, and best wishes from Munich. I had some private topics here around to dial in time. I'm very sorry for that, and thanks for shifting the agenda and jumping in here. So I prepared some slides for you guys to give you a look back on AUTOSAR, to the current state, and then also for the future. And let's discuss also partly at the end where we can go with the Indian region in future. You've seen the car before, and if you remember the iX, it's one of the cars we are providing with BMW. Both software platforms, adaptive and classic, are included in this car. And if we continue now looking to the past, we've been quite successful in establishing this standardization framework around AUTOSAR, which is since 2003. And it includes like e-architecture design and mobility in general. So what's to say? We have a really important thing that the global idea is for us quite important. We don't know borders from the perspective of political topics, and we see more and more the technology like overlapping over the regions. And it is necessary that we are able to talk about technology beside all the other things. And if you look on the principle, you know that the value chain in OEMs is starting, and there the invests are coming from. Also, they have to be responsible for the delivery of the cars. That's why AUTOSAR is enabling the whole technology around it. So we have 2-3 years before it starts with the whole serious development. We try to place our technologies in the AUTOSAR consortia and bring them in, that they are available to the whole supplier industry. If we look to the partnership itself, we have a significant coverage over the world. So the core partners were introduced in 2003 to 2007, and then it took its path to around 330 partners at the moment, which is quite distributed. And we see also a very good construct working in Japan with us. And the US region is kind of an open world with a lot of startups. And in China, there are some things ongoing that are more like driven from an authority perspective. But this is for us more a challenge than that we are against that. And it's very important for us that we have these partners in place for our serious development. That's why the core partners itself have a quite good understanding where we would like to go for. And the premium partners are mostly helping with exploitation license and development license. There are also smaller companies like in the development partnership area, where we focus on specific tools and methodologies and support the whole idea of AUTOSAR for the future. What we should not forget is that associate partners are a very good idea to interact with the region, but also simply deploy and simply use the standard locally. That means they are still connected to the community and retake what's everything available in the release and reuse it for serious development. So we have a quite significant rate, which is from development license to exploitation license going. And this is 134 associate partners just using the standard, which is a quite good idea of a licensing model. Who's steering the organization? The core partner are in fact bringing in management roles in the white areas, and then they are supported with strategic partners on project leader team level. And I can announce that we will replace the strategic partner program with the Premium Partner Plus program in future. That means that everyone who is able to bring in technologies and also significant interest to the technology steering can be part of this organization. Below that, there's the magic going on. So in fact, there are a number of groups that are really handling different platforms, adaptive and classic. This is the two areas where you see below different activities around execution management for adaptive and demonstrator integration, persistency. And on the left side, you see the classic platform as an established platform, working groups where runtime environment and libraries are included. And there's a cross-standard idea of working groups above, with a lot of cross-cutting topics around resources, diagnostics. The biggest group is in-vehicle communication. It's IVC on the right side. And time synchronization, which means that we have a common time base in the car, which is the most important thing for the safety angle. And if we look to the past, there is a matter of knowledge transformation, a matter of knowledge increase in the automotive industry. Starting in 1970, there were like mechanics ideas about how we automate things. And then we now in 2025 in the so-called zone architecture, which will be implemented with BMW, with VW, with a lot of others OEMs, where we see domain-directed big high-performance cluster, HPCs, or processor architectures as SoC infrastructure as well. So we have here a bigger idea of computing power in the car, in the central part, and then have also some sensors around sensor architecture with classic platform, for example, included. That's what we call the zone. And this is the thing to follow for 2025. How do we support it from AUTOSAR? In fact, there are non-AUTOSAR basic software platforms. We have adaptive platform in place and the classic platforms. The classic platforms are simply like microcontroller oriented, smaller ECUs, but they have also a big idea of safety and security. And they need, of course, on system level to interact with adaptive platform, where on bus level, it must be, compliant to each other and also supporting each other with the right protocols. And if we look to the classic platform itself, we have a big idea of functional safety. At the first place, we see the efficiency and the proven record of in the field that we have a number of supportive suppliers in place. I know some suppliers from India that are really like having own stacks in place, using this to exploit that as well. And the performance that is, I think, significant. I've seen also inverters running with microseconds in the task schedule for the classic platform. On the adaptive platform side, we also think of 3 pillars. Like the first pillar is safety and security. It's called dependability in the automotive area. And here on platform, in vehicle and external communication, there are measures in place for supporting this. A big step forward is in the area of connected or connectivity, where other standards are interacting with us. Things like REST or DDS with ROS2 are something that we have to admit is something that is important for us, because the whole adaptive platform is based on service-oriented communication. And this is a big difference to what in the idea to the classic platform. Last but not least, we see as well the updatability, the need that safety and security parts can be done, can be updated, not during runtime, but maybe during standing inside the car or parking. But we need to update software inside of our HPCs, the domain controllers, in fact. And also, if we compare now classic and adaptive, the milli and microseconds real-time requirements are significant. On the other side, we see safety critical requests for ASIL-D in classic level, which can be provided. And the first platforms are going to ASIL-B with adaptive this year, the first suppliers. So it's a good sign that after, I think, 4 years standardization adaptive, we see more and more confidence for the adaptive platform. Going forward to the release 21.11, that means we are now in the present. We look to the past, and in the present, in the release 21.11, there were some significant updates on the foundation level, especially system health management, a new protocol for log and trace, and some updates in the area of communication, and also the timing and tracing approach, which is important, I think, for some of you, is included, a unified approach here. We built on top of that a classic platform where some flexibility discussions are ongoing, and extending the Ethernet profile with the 10BASE-T1S profile to have a kind of more low-cost idea of the Ethernet implementation. And I would also include the OBD on UDS inclusion to this, which is homologation relevant. The other side, adaptive platform extends from the end-to-end protection view, the fields, and the architecture designs are giving the base for this, for both platforms for the future. And what we sometimes forget is that the adaptive platform comes along not only with specification, but also with code. We release the code in this month, so in April. So stay tuned. If you're an AUTOSAR partner, you can have a look to the source code and maybe build the image for you. If you look to the lines of code, the adaptive platform increased, especially in the last release by 60K, 70K lines of code and some more files. So there is significant feedback from the community. And that's how the standard looks like. I mean, we are applying to the foundation, the classic and adaptive platform, and built on top then interface descriptions and also the acceptance test, something which is mostly covering a past. Good. So all in all, the 21.11 release is in numbers. We have around 2,100 incorporation tasks with a number of change requests in the AUTOSAR community. So there was some things to discuss. And we have 134 collaborating partners in 20 working groups, 300K lines of code, which is not too much, but it's growing, the adaptive platform demonstrator, and new concepts were introduced to standardize two platforms in one holistic architecture. All right. Do you have questions until now? Because we looked now to the past. I was rushing a bit. We've been now to the present. And before we look to the future, let's maybe have a short round of questions, and then we go on the future discussion. Did I lose you on the way? Do you have questions? Is there anybody?
You're good, Rinat.
Yeah, you hear me and I can continue, or is there any questions?
Yeah, we can continue. Before we continue, can I just make one small announcement about the session being delayed for the next speaker? Can I just make a small announcement? Yeah. So, friends, I just wanted to give you a quick update. Our session is being delayed. The next session by automotive security in a car by Eswaraiah will be delayed by 30 minutes. So please stay online. All right. So he will be the next speaker. Thank you. Over to you, Rinat. Thanks.
Yeah, thank you so much. And I'm the reason for the delay. I'm very sorry again for that. And yeah. But that's sometimes unplannable things in the back, so sorry for that. Yeah, and let's look to the future. How does it look like for us in AUTOSAR? In fact, we see a bigger integration into HPCs. That means that the whole topic around SDV, software-defined vehicle, includes a holistic view on several platforms which are running on one processor or several, and then we have a possibility to create a whole, I wouldn't say OS, but SDV approach, including the backend and the applications. So several platforms running beside each other, including applications on top and the backend communication. We wrap that with an SDK, and this is for us the future of standardization as well. That means that we don't have any lags in the idea of integration. We simply take this whole image and bring that to the integration to the cars and are faster in the deployment. That's an idea how we'd like to follow that, and we will now have a look what, functionality-wise is important. We are based on normative standards. That means the ISO, SAE, IEEE. Here we look to systems engineering, automated driving, and the backend communications. And that's for us quite important to cover these three angles. The first thing in the safety systems engineering, the traceability must come from requirements going to the implementation and being verified and validated at the end. And when it comes to to automated driving, we have to think about how much can we trust the car in India going alone without driver. I maybe looking to each region individually. And I think there is some areas where such use cases can work, if it's night or if it's a kind of separated private area. But have that roll out in the whole field by all OEMs, we must increase the confidence in the technology. That's why availability, safety, and security is key. And we have to build on that a kind of intelligence that we can trust the car and that it shall go beyond the current safety mechanisms we have. If you look to the safety ideas, and this is for me, technology-wise, the biggest path to handle, we have cybersecurity on the left pillar, safety, the safety path, including the SOTIF idea. And on the right side, there is a development path that is going in the serious development, which means it has to interact. And for every ECU, you might know that, we have from the OEMs to sign a kind of agreement that we have fulfilled the state-of-the-art technologies. And we are signing this based on standards. So AUTOSAR must follow what ISO is proposing. And therefore, we can increase the automated driving idea together by creating better standards. And I think this is the most technical thing we can directly look together on. If we connect the car to the back end as a part of the edge, and we can include the existing standards such as a VSS or VSC to it. The W3C standardized VSS and VSC as data tree that covers the whole car without having any deployment-specific information. This is quite interesting and good for us because we simply can attach to that and create a common interaction with the car as part of the edge. Okay, and this slide I really wanted to only drop with you because this is a kind of out view where we are going. That means you have here a look, even as a non-partner, on concepts that are currently in elaboration in AUTOSAR. So this is part what we see as big steps, as feature steps inside of the AUTOSAR organization. That is why I really would like to highlight we need every soul to push with us. Yeah, so if you have interest in any of the topics, if you would like to be part of a working group, just let us know. Go together with your management to the partnership. We are quite open to discuss, and we can include you to the discussion. You can see as well here the vehicle API on the right side as an own flower part. And that's the one. I just highlight maybe one or two of them. Why it's not? Oh, it's only the laser pointer. Let me check. There you go. So the vehicle API, for example, is a quite important thing. We have max security for both standards as an important activity as well in the security area. And I'd like to highlight on the classic side the secure time synchronization. And also I think UIP is quite important that we support it properly in the classic platform. All right. This would be a big flower field, but yeah, come back to us with your questions also on LinkedIn or on the AUTOSAR organization side. So I just try to summarize. We are a quite established partnership and have definitely a good understanding of globally created kind of ecosystem. And we see also safety and security as a big part of our organization. And we would like to push further with the ecosystem as the mobility standard, as under the roof of AUTOSAR. My last part is more a view to India, because I also would like to be present more in your area, in your region. And that's why we created an activity for next year, which we would like to announce also today. We would like to create an India Day next year, an AUTOSAR India Day, where a lot of companies can come together and discuss how they can improve the regional creation of India. That's why we started a new activity. It's called the Hubs and a Regional Spokesperson. But to get to a hub, to an AUTOSAR hub, you must create a significant number of partners to come there. And as you see, we have here some background. We are kind of Europe-centric, but we have also goals to go for third parties and the opportunities we see in each region, like in India. And we'd like to represent AUTOSAR on regional events and also coach you guys in the idea what we have in coming from Europe, for example. How I'd like to build that up. The evolution of hubs starts usually with a regional event, for example, with an India Day, and which will be next year. Then what we do as next step is that we kind of create a user group. That's what we would like to initiate. And after that, it will be a bigger, significant, I think, ecosystem with a hub after 25 partners. If we see that running after some time with 10 to 15 partners, increasing to 25, then we create a hub, which includes a regional spokesperson, administration, and also user groups and events. And if you look to India at the moment, we are in the middle part, which means we have around 13 AUTOSAR partners from this area coming. They are mostly bigger companies because they have also like connection to Europe, to other areas. But I also like to invite the smaller companies that can contribute in specific areas to this kind of activity. All right, I think that's mainly it from my side. I hope I could a bit win some time, and it's 25 minutes. And maybe if we have 10 to 15 minutes, a small discussion, this would help all of us. And yeah, I'm looking forward to your questions and hope I catch somehow your interests.
Yeah, good morning. Can you hear me?
Yeah, I do. Thank you.
Yes, currently we are using HCP or HPC, the ECUs, right, in industries.
What do you use in HPC, sorry?
HCP ECU, currently we are using in industry, right?
So in the industry, we're using on the ECU level, mostly microcontrollers, which are very deterministic. And now we are more extending, like in the infotainment clusters, the processor architectures like an Intel, ARM, NVIDIA, include that to also onboard systems. And this is where I think from the hardware perspective, the biggest changes are coming from, yeah.
Oh, okay. Thank you very much.
Mm-hmm. I hope I catch your question. I don't know exactly.
Yes, my question is like currently in industries, they are using HCP to test the AUTOSAR applications. And what is the next generation ECU that we can expect?
The next generation ECU is, we go back to the technical part. So if you look to this picture, for example, you have a vehicle computer in the middle, which has the biggest challenges because you see here domain ideas consolidated and several parties integrating software to this. So it's not like a unique contract to one supplier, like maybe the other ones, but you create together with the OEM in an ecosystem different partitions. But on every partition, there might be a different OS running, things like ROS, Android, Linux, Adaptive, Classic. You have some choices, and you build then on top your applications on different language bindings even. Yeah. For example, we are experimenting a lot with Rust a bit because the libraries and the language is growing, and C and C++ are established. But if you look to the backend, they are also having quite different languages like Go or Java or included. So we have to be more flexible on these central areas.
Yeah,
okay?
Got it. Mm-hmm. Thank you very much.
You're welcome. Next question. I'm really looking forward to yours. So if you have any open ideas on any of the slides, I can go back as well.
Yes, I have an idea related to the adaptive AutoSAR, where we can monitor the health condition of the driver, or else the person who is inside the car. Like this, which is very important. Mm-hmm. So I'm a student in Technical University, Cambridge.
Oh, cool. Hi. Yes. You're not too far from me.
Yes. Currently, I'm in vacation. Right now, I'm in India. Mm-hmm. So I have some plans to develop some applications related to adaptive AutoSAR or Classic, even for the vehicle-to-vehicle communication. So I will come to you as soon as possible with my ideas.
Yeah, I mean, that's also a good statement. Keep in mind that every university has a free of charge access to the demonstrator itself. So you can create a so-called attendee agreement with AUTOSAR, which is completely without any costs. And then you have access to our GitLab. And I can even a bit show you how this looks like at the moment, before maybe next question pops in. And with the attendee agreement, we include non-profit organizations. That means we see here a benefit to collaborate with third-party organizations or universities and increase the knowledge then inside of the students. So you see here a project which is under code AUTOSAR.org. And we have a Pi car, which is a Raspberry Pi, where we migrated the code base and just running in circles without any with a recognition, in fact. And if you look to ARA API, it's the ARA API that's provided with the specification, and you can have a look on every function cluster here. And so you see here also some people contributing to this on a daily basis, and that's quite, for me, it's a quite important and interesting step because the people are not discussing on specification level, but also mostly contribute to the code directly. All right?
Yeah,
Good, then let's continue.
Yeah.
Any questions? Maybe from the others as well?
There's a question on the chat window. Okay, what is the role of Rust programming language in AutoSAR?
Perfect. That's a good one because we're just starting at the moment with two different documents. So the first document is to have a description how to integrate software to the adaptive platform. So it's more.
Vishnu, can you put the background on mute for the others? There's some noise.
Let me check. Can I do that? Yeah, no, thanks. Better. Yeah, thanks. And the point is, Rust has an integration manual idea for the first document we will do. That means that we can know how to place or how to integrate the adaptive application based on Rust. And of course, this comes with a binding discussion of the middleware, but this is still open, how we can do that based on which language. So we can reuse maybe even our C++ APIs for the moment. We are double checking this. And the second thing is a coding guideline. Similar we did for C++ 14, which accelerated, I think, the C++ usage in safety critical systems a lot. And the same thing we will do, we will try to accelerate a bit from the Rust perspective. I hope that answers the question. And the next one is coming by chat again. Thanks, Venu Sharma. Is automotive industry will shift controller to processor for good performance? In some processor memory is inside the pro. Yeah, that's it. I mean, that's quite interesting because with the best of both worlds, you can do the best for automotive. Microcontroller architectures are built to be deterministic, to be sure, to be if boss comes to you or a manager and says, hey, we have here a problem. Could you just say how the log looks like at the moment? Where is the problem coming from? You're having the same behavior on the microcontroller as always, like it's deterministic. You know where you are. On the processor architecture, you have a memory management that gives you more flexibility, and it gives you also a better way to be with bigger data approachable. But on the other side, you are not in this reporting loop. You can't be sure on every state that you are in this step. And that's what makes the whole discussion at the moment quite awful, honestly. And on the other side, we also see that the service-oriented architecture, that's more from the backend systems, a state-of-the-art thing, is just entering step by step to the automotive. So we have the signal-based approach, based on time, based on data types, and then we come here with API-based approach, which is based on service discovery. And it's clashing, and that's very interesting because it clashed directly in this huge ECUs, and we have to create confidence around that. So I hope that gives you a bit of an insight to the discussions ongoing around this transformation we enter. Yeah, more questions. You have no questions to the event itself. I mean, next year we would be from AUTOSAR would plan a kind of activity, and we hope, of course, that some of the partners are interested maybe to host, to organize with us, to be present. Yeah, what do you think about that in general?
We actually look forward to it, Rinat. We are actually looking forward to build a very strong and robust, and in fact, a very active community which can participate to contribute to AutoSAR.
Sounds very good. And
feedback that we get from many of our friends who work in the industry.
Great. So let's maybe really focus to create this green rectangle again. And I know there have been an AutoSAR day once in a day, in some days or some days ago. But for me, it's a goal in 23 that we can build up this user group with associate partners and development partners that can discuss about regional challenges and then bring back by some partners to the AutoSAR community. So we don't lose grip in your area. That's for us an important step. And that's why I'm also here today to announce that. All right, another chat question. Currently, I would say that's the last one. If this is okay for you guys, from timing perspective, some issue are running. Okay,
let's take this as the last question. We'll write to you for future if we have any further questions.
Great. Yeah, the question was around currently some issues are running in older versions of AutoSAR, and new versions have more reliable security. So OEM change older version to new version, and it is a big change. Yeah. the topic of legacy is, I think, visible in every industry. And there's also some companies just starting from the green field, like from zero, and they have a good idea. But the point is they don't know any history, so they might do mistakes that the RMs did like 5 to 10 years ago. So there's always a good and a bad thing in covering with your legacy. With legacy, it's a problem to maintain knowledge and also like IT infrastructure for that. So for example, to support at the moment the 403 standard of classic AUTOSAR, let's find the tools for that, and let's find the baseline of code we had there. So it's always good to follow with the newest version. And we have in AUTOSAR a so-called backward compatibility idea. So we don't want to include too many changes that are backward incompatible. That means that the APIs are completely reordered, right? This we only do with the big changes in the releases every, I don't know, 5 to 10 years maybe. But if you have yearly a change in the API, you could not follow the development. That's the background of that. All right, then best wishes from Munich again. And one question. Now it's two questions. I have to read them out. One question is forming a regional user group, tackle regional challenges, create. No. Jasper and AUTOSAR has a strong relationship. For example, in Japan, there's even a working group on AUTOSAR in Jasper. So we don't want to interfere the regional idea we have in Japan. That's why we're connecting. So there will be a press release just in the next months that we are creating together in MOU on this purpose. And we are kind of accomplishing each other in the ideas, and we can then bring back from Japan the feedback to AUTOSAR and include it by the 8 to 10 partners we have with the development license. And the second question is trend. It's in fact, I just read it. As trend, we have improving AUTOSAR from classic to adaptive will be consistently more towards cumulative and towards adaptive technology or architecture we will be following in the future. I think, more and more classic will be as a kind of commodity idea, but we see also that if we get a feature, for example, for security or time synchronization, it's a system feature. You can't cover this by only covering the adaptive platform. So we have to tackle the classic as well. We have to change it. Key management, certificate management, identity access management. Those are all security features that are necessary for 2025. And they are tackling both platforms. And on the other side, you have time synchronization, which we need as a safe time base for the future. So that's why both platforms will be enhanced step by step. And that's why, stay tuned on those. Okay, let's do a full stop here, and I'm looking forward to the questions afterwards as well. And stop sharing and wish you. No, I don't want to do sharing here.
Yeah, thank you, Rinat. We are also pleased to announce that ANCIT is also part of the AutoSAR Consortium, and we are working towards making India as an AutoSAR hub in collaboration with Elektrobit. We've started that process as well. And for you all folks, you'll seen we will reach out to you very soon on this collaboration, and we look forward to drive this user group for AutoSAR in India. And soon we shall reach out to all these companies, and we'll also take the support of Rinat and his team and see how we can work together in making a strong community in India as well. Thank you, Rinat. Yes. Thank you so much. And thank you so much for joining us and in spite of all these technical bugs that you had in the morning. Yeah,
it was less technical. It was more personal. So I was really a bit disturbed.
I know we could handle technical things,
that.
but personal things get better of us. We completely understand.
Wish you also a nice Saturday. And as I said, we need every soul, also every technical person. The software developers are rare, and that's why we are looking to you guys, of course, as well. Thank you so much. Bye bye, everyone.
Thank you so much.
Rinat. Thank you.
Thank you. So Rinat has set the context for the next speaker. He has mentioned many times in his speech about the future of the vehicle, and the future of the vehicle stands with three important categories: security, safety, and also building the confidence in the customer. So these are three very important aspects as far as how the car or the future of the car is going to be. And on those lines, we have the next session and the next speaker. We have an very interesting and an exclusive topic, which is gaining momentum in the market right now. It's on cybersecurity in the car, or the cybersecurity in the automotive. And to speak on it, we have a very experienced person on automotive domain, Eswaraiah. Eswaraiah has around 15 years of experience in the automotive domain and in AutoSAR. He has worked on various AutoSAR stacks like, say, Diagnostic, communication, and Watchdog. And he's also been part of various organizations in building the bootloaders for ADAS-based ECUs. He's also an ISO 26262 functional safety certified engineer, and he's also a certified cybersecurity specialist, ISO 2143421 and SAE J3061 by Omnex. So there are a lot of certifications and there are a lot of credits to its rank. I'm sure I will spend another half an hour to read it. So on this short note, I would like to thank Ishwar for extending his session. Thank you for all the patience, and thank you, Ishwar, on a personal note for joining us and also helping ANCIT through all this journey. And it's over to you.
Yeah, thank you. Thank you, Karthik. Thanks for that. Okay, so let me share my screen. So are you able to see the screen, Karthik?
Yes, Ishwar. Yes, sir. No, okay. It's still not visible. You have, yes, it's now opening up. Yes, it's visible.
Yeah, thank you. Okay, thank you all for joining this afternoon, and welcome all for the very hot topic in automotive industry, that is cybersecurity of car or the vehicle, I can say. Okay, so yeah, let's start. Okay, so hope I am audible to all, and presentation is visible. Yeah.
Yes, Ishwar. Everything is fine.
Thank you. Okay, so you would have already seen this picture about the Jeep hacking long back, and you can see there are a couple of examples I can provide, but I just kept only one popular example here: hacker remotely killing a Jeep on a highway, right? So this is very popular example where each and every session it will be keeping on coming. So this has been happened in 2014, right? So if you see that hacking is not new, right? So it is keeping on evolving and hacking it. Okay, so let's come to a very interesting journey. I hope you would have seen this picture, Fast and Furious movie, right? So where you can control the cars at any point of time remotely, and you can play with them, right? So this is where we are now in the future and in the current as well, right? So just to motivate all, so I recommend you to just watch this series and you can see what we can do remotely with the cars, right, after hacking. Okay, so is your car is secure? So you can interrupt me at any time if you are having any doubts or clarifications. So it should not be a monopoly talk. So I can recommend you can speak up if you are having any points. Okay. So is your car secure? First, yes, I can say it is based on different security controls what currently we are having today, right? But not for tomorrow. So this is what I want to bring it very strongly to this forum, that currently whatever we are contributing towards the security of the car, right? So it is only for today, not for the tomorrow, right? Is security for car, I can say it is just a journey. It is only a comma, not a full stop. Okay, it is not a destination. It is only a journey. So this is what I want to keep related to the cyber security. It is keeping on evolving every day, right? So this is just a glimpse of recent attacks in automotive in last year, January, February, and June, right? If we can see, there are a couple of attacks on the ADAS, right, in the Tesla and the Mobileye and the autopilot systems. You can see in Feb, there is 19 different vulnerabilities which are found in Mercedes E-Class car of controlling of the vehicle remotely, right? In June 2020, you can see Honda, and they stopped their production for some time because of their network targeted networks. Okay, it has been hacked, right, with ransomware. So these are the different, I can say, the truth which is in the public forums. You can see the links in each and every slide. Everything is publicly available, or the information what I'm providing here, right? So you can refer and you can get educated to this. Okay, why is cybersecurity becoming very hot in automotive? So this is where we want to understand, right? So previously, the automotive cars are not hacked because we don't have connectivity, right? And we don't have the infotainment systems. We don't have entertainment systems in the cars. We don't have telematics. We are unable to control remotely. We are unable to do the tracking remotely. We are unable to, we are unable to do the tracking and monitoring remotely. But nowadays, we are evolving in the features. So we are making our second home as a car, right? So the moment you are feeling that your car is a second home, you are expected to see the same movie what you are seeing in your home. You want to continue the same, right? So you want to know the information where you are going. You want to know the roadblocks. You want to know what is the available where, right? So that and all, everything can be possible through this connectivity. That is our V2X, where we can do vehicle to infrastructure, vehicle to vehicle communication, vehicle to devices, vehicle to pedestrians, vehicle to grid, vehicle to network, right? So this is all, with all this V2X, we are able to have different features than the previous cars and the current and the future, right? So this making cybersecurity very hard, these features, because the moment you are connected to the world, car is like one of the node in the network now, right? And the moment it is connected, so it is always exploitable by someone else, right? and you are having your information systems. So information and entertainment. So you are getting some information into your car from outside world, right? So there is always a chance that your car information also can leak outside the world, right? So that is why we are having the cybersecurity in automotive, why we are talking today, right? And we are having the telematics also, because someone wants to monitor where you are going, right? How you are driving it, because there are a lot of legal regulations, right? The way how you drive, the way the speed, how the vehicle is going. So everything it is monitored and tracked. Based upon that, there are a lot of insurance business is revolving around it, right? So this is where these are the different enablers, right? To think about the cybersecurity inside automotive. That is why we are talking today, and it become very hot, right? Suddenly, okay, let me go to other slide. Oh, sorry. Okay, so these are the different, again, a small other examples like shared mobility. And we are thinking that we don't want to drive the car. We want to just sit and do other things than the driving, right? So that is where it is possible because of the connectivity, right? And the control, the safe control. And we like how we are using our mobiles, right? So if there is any updates on the mobiles, so we are updating the software without going to a service station or I can say the mobile provider, right? We are just updating the mobile software on our own. In the similar way, the photo, it is firmware over the air updation or software over the air updation. Why I kept these three is because all three are same. It is only a different names, right? And we are going for a digitalization. We are shopping inside car. We are paying from car, right? All our credit details, our personal details is within the car now. So that is where is the future and the current, what we are aiming to. 1 minute, let me keep some pointer. Okay, right? So, and we are having the electrical cars, right? So that is where also we want to charge, and the charging guns is from the external again, right? So there is a probability of we need to secure them. Otherwise, there will be a mismatch in the battery life, right? And it is a threat for the point A to point B for the user, right? So these are all different enablers why we are talking about cybersecurity. So yeah, okay. So I just want to take you through how the market is looking like in future with respect to the automotive cybersecurity, especially, right? So this is one of the paper from one of the famous market. So you can see the graph as per them. So these are the different systems: ADAS and safety systems, infotainment, body electronics, powertrain, and telematics, which are contributing, and the size of the in US millions of 2025. So now we are here, and you can see the graph. It is increasing. Means we should also get ready to address this market, right? So there is a lot of money involved, lot of technology involved, and a lot of things that we need to get prepared, right? So this is the future, guys. So we need to capture it, right? It is like I can say that it looks like a hill, correct? So it is up to you how much you want to grab from the hill, right? How much readiness you are having, how much time you are having. what are the different tools that you are having to dig this hill and get what you want. So that is up to us, right? But this is very interesting graph, I can say. Okay, so what are the different cybersecurity segments in and around the vehicle? What can secure? So we need to secure the hardware, right? We need to secure the software, and we need to secure the network, and we need to secure the cloud, which is providing the V2X and VOTA, right? FOTA, SOTA, right? So these are the different enablers, what we need to secure as part of the your E&E systems of the vehicle, right? So, and what are the type of vehicles you can secure? You can secure the passenger and the commercial vehicles. And you can secure the other vehicles as well. Yeah, okay. So what are the different applications inside my vehicle? So we are having OBD, we are having different communication channels like CAN, CAN-FD, SPI, JTAG, Ethernet, and FlexRay and LIN, whatnot. And we need to do the safety ECUs also, because the safety ECUs, when it get compromised, then there is a threat to the user, right? And we need to very much secure about the infotainment and the telebox, because these are the entry points which is connected outside the world, right? So we need to have the security around these particular applications, especially to provide your security in and around the vehicle. Okay. So how the hackers can hack the vehicle, right? So there are different varieties we can do it. I just kept very limited points here. One is spoofing of your messages and manipulate your code and the data which is there in the car, so that the intended functionalities will not be performed, right? And it will be unintended, right? You need to sending a harmful messages through your infotainment and telematic systems, and you are making abnormal, right? Suddenly you will increase your volume. Suddenly you will want to try to control your steering. Suddenly you want to keep the brake. Just imagine when you are going around maybe 100 and 120 kilometers per hour, and suddenly if someone is braking your car, what is your situation? What is inside car situation? What is the outside car situation, right? So it can be possible remotely, right? So this seriousness that we need to take. And we are keeping our mobiles charging inside the car, and we want to mimic the mobile screen to the car, right? So all these things, you are enabling the hackers to access your car, right? And taking the advantage of vulnerabilities. What is meant by vulnerabilities, right? So the loopholes which is existing in the current version, right? So these are the different loopholes you need to keeping on monitoring. That is why your car is not secure tomorrow, because someone will find out the loophole in your system, right? And take the advantage to take the data of your personal data, or it could be a car data where they can manipulate the things, right? And they can play with you. They can threaten you. They can play. They can go for you at the worst extent to make you an accident, right? And denial of services, right? So we know that all our CAN protocol is based upon arbitration, right? And we know that the lowest arbitration will acquire the bus, right? You just think about when you are having a lowest arbitration and keeping on acquiring the bus, what will happen the other messages which is exchanging between the ECUs, right? What is the decisions based upon the content of the signals the ECUs has to take, right? So definitely the intended functionality will not happen, right? And it will be a disaster. And you are keeping your mobile, and you are keeping your credit card details and everything. So now we can claim that mobile is part of our body, right? How many you agree or not, but that is what is reality, right? So so hackers can embed the virus in your communication channels. They can manipulate, right? Malicious content which can received by your vehicle. So they can do that, and they can enable your JTAG, and they can totally replace even the binary which is there in your ECUs, right? This can happen. So these are the different snapshot of what hacker can do with your vehicle, and what he can gain, right? So this is just one of the example where there is a can hack. So you can do this through your telematics units and infotainment unit, and you can take wireless attack and injection the messages, and you can manipulate the need. So this is just an example what an hacker can do, right? So what to follow in automotive to address the cybersecurity, right? So I can say that, okay, what is mandate as per European regulations, right? So UN 155 and UNR 156 is mandate, and EU GDPR is mandate. Okay, so this is coming from the regulatories, right? What is not mandate, which is highly recommended. Everyone knows that we are following. If we are talking about cybersecurity in automotive, everyone knows this number 21434, right? But 21434 is a highly recommended, but it is not a mandate. So please check your things. It is only the highly recommendation, right? Highly recommendation for the physical vehicles. This is a guidebook from SAE, and ISO 21434 2021, which is released last year. So this is an highly recommended. It is not mandate again. So please check. ISO 2771, it is an information security management system, okay, which is beyond your vehicle. This is off vehicle things which will support your GDPR, right? Which will talk about your infrastructure, about your information security. Because why we are talking about this? Because we need to talk to a cloud, right? The car is talking to the cloud now. So the OEM is providing the photo information, right? So how secure the car information, that is what we need to check. How secure the user information which is collected by the OEMs, and how secure your credit card details or your hard-earned money can be tampered at any point of time, right? So we need to be very, very cautious about these things, right? And it will be for day to day, right? Not only with the car. So you need to check the information and the mobiles, and we know that we are just making click, and we are accepting the conditions, and we are giving the control to some other person, right? And these are the recommendations. NIST, National Institute of Standards and Technology Standards, and Automotive Spice for cybersecurity, they have released, VDA has released it. So you can go through Automotive Spice for cybersecurity as well. to address your needs of 21434 and to have the ECU development, right, as per ASPICE. Okay. And what are the different EU regulations to be followed in automotive cybersecurity? So apart UNECE Work Package 29, UN regulatory bodies, it is 155, it is CSMS, and 156, it is SUMS. So the CSMS is Cybersecurity Management System, which will include related to the OEM and also part of the tier ones, right? So we will take a snapshot of, I will go through the overview of 21434, which will be addressing the CSMS. So CSMS is at the organization level, but the project, the vehicle, what you are working is a subset of this CSMS, which is tailored for your program or for your particular ECU development activity, right? And software update management system is how the OEM is managing the FOTA information, how the systems should be there, how it has to be secure, right? So these are the different, we're having each and every ECU is having their own type of approvals. That is called RX Win ID in SUMS terminologies, right? So you need to have those particular Win IDs and type approvals from the authorities to claim that you are following these regulatory bodies, right? You need not follow 21434, it's fine, but you need to follow these regulatory bodies and show that, okay, so it is only a recommendation, okay, but this is a mandate. But how you are compliance to this and get the type approval at the vehicle level, right? So that is important, right? But it is recommended, highly recommended to follow 21434 for the CSMS, and there is one draft version for 24089. Recently, it has available for the public to buy. So previously, it was under the draft and it was not able to release it publicly, but it is now, it is available. You can see these snapshots. So you can take 24089, which will be addressing about the software updation management systems at the OEM level. And at the same time, this is not only the OEM, because OEM is the vehicle is nothing but your E&E systems, correct? So all tier ones has to get educated about these standards, and they need to figure it out what is their roles and responsibilities in these particular standards and how they can support to be compliance with these regulations. That is very, very important to address in the automotive cybersecurity. Okay, so I can give you the overview of 21434. You can see the 5th chapter will talk about your organization level cybersecurity management system, right? Which will talk about the governance at the cybersecurity at the organization level. What is the culture as an organization you are taking? How you are sharing the information between the internal departments, between your customer, between your client, how you are managing, how you might be using a lot of tools to manage your programs, right? So how securely that your systems are there, right? And you might be using a lot of tools, right? All the tools will not be accessible to each and every one, right? So that way you need to secure your tools management, and you are not sharing information to each and everyone with your employees or outside employees, correct? How securely you are following your information security management, right? And at the same time, when you are keeping all these in place, right, you need to have an audit, organization level audit, how you are defined these things, how you are following these items, right? And either I'm following correctly, which is intended as part of the process, and how I'm implementing it and how I'm maintaining it. So everything will be getting audited, right? Now will comes about the product development, cybersecurity management. If you see this is at the organization level. Organization may have a lot of products, lot of projects, right? So this 6th chapter is depending upon your project, right? Cybersecurity responsibilities. What are the different responsibilities related to the project? How you are planning it, right? To have the governance at the organization level. How you are tailoring it, because each and every project is unique, that we know, right? So all these norms and all these tools, all this information, is it relevant to my project? How I'm tailoring it, right? How I can reuse from the different projects. That is also another class. How I can component out of context. How I can keep in my project. How I can reuse off-the-shelf components for my project. How I can show my evidences. How I can gather different evidences from the organization towards the project and also towards the development life cycle. That is what is the case is all about. When you are doing all these things, definitely you need to cross verify with assessment, right? How I am doing it. Either I am doing it rightly, right? And either I am following as per the plan, right? And why it is very important about release of post development, because the statement again I want to repeat here. Car is not safe tomorrow, right? Car is only safe today. So we need to have the post development activities to monitor always about the vulnerabilities and to be keeping on checking. That is the reason you need to have some development or some progress or some activities post the development also, right? Distributed cybersecurity activities. So you cannot do it alone, right? So you need to have the suppliers to make a car, right? So your E&E systems cannot be developed by the OEM, everything inside OEM, right? You need to take help of tier 1s, tier 2s, right? So when there is particles of your organization in particular program, right? You need to check with respect to the supplier capabilities. Either they are capable of performing cybersecurity for my E&E systems or for my OEM program, right? Request for quotation. So you need to first evaluate them, then quotation is based upon your project, right? So you need to get the quotation, what are the activities that they will be doing, what is their alignment of responsibilities, right? We'll be having something called as a CIA, Cybersecurity Interface Agreement. Supplier capabilities will be having some evaluation sheets, right? So these documents you need to fill and you need to evaluate your supplier. Either it could be a tier 1, OEM to tier 1, and from tier 1 to tier 2. When we are transferring some of the piece of the activities from this program, right? So you need to cross verify either supplier is capable or what is the responsibility of the suppliers in this particular project. Hello, Karthik, I am audible?
Yes, sure, you are audible.
Okay, thank you. Okay, so continual cybersecurity activities. So as I was telling, cybersecurity is not a full stop, it is a comma, right? So you need to always monitor. You need to cybersecurity event evaluations you need to do. What is the event is occurred? It may not be occurred at your project level, but around the world, someone is hacking telematics device. So you need to check your telematics device. Is similar? Either that activity, that event can happen to my car as well or not. So that analysis you need to do. The vulnerabilities, what is coming every day, you need to cross verify with your systems. It may not be happen that your own system is not hacked, but someone else's system is hacked, but you need to cross verify with the same kind of activities, right? And how you are managing them, either you are managing frequently or you are managing the incident based activities. So this clause will tell about the how you are managing it, right? So this is related to the concept phase when you come to the your E&E system development activity, right? You need to provide your item definition. You need to be very clear that what is your boundary area, right? You cannot take the entire vehicle as a boundary, right? As part of the item. So you can derive your own item. You can keep your goals. You need to do the Tara analysis, which is at the 15th, right? And you need to have the goals and the concept. Then you can have your requirements ready, right? And this is your product development life cycle, where you want to do the design, integration, verification, and the value validation with respect to E&E system. So you need to design your architecture about E&E. You need to do the integration and verification related to the cybersecurity goals and requirements what you have derived from here. And you need to validate them by doing penetration testing, fuzz testing, and your unit testing and MISRA compliance and CSAT-C compliance and C++ compliance, whichever language that you are using to make the production of your ECU, right? And this is a post-development phase. Again, you need to take care of your production related to the how your information is sharing across your tier ones and the OEMs, how you are managing them, what is the different tools that you are managing at the production level, right? How controlly you are accessing the tools at the production. So all this information should be there in the clause 12. And class 13, operations and maintenance. So how your incident response, if there is any incident to your particular car, how you are responding it, what is the timeline that you are responding, the moment it is incident has been happened, what is the information that as a company you should know, what is the information that you need to give to your end user, what is the information that you need to give to your suppliers, right? So all these things need to be very clear in the incident response time, along with the information exchange and also the timely you are responding to the particular incident, right? And how you are doing the updates. For example, there is an ISO 21434, right? So how they are doing some updates, you need to keeping on monitoring it. If there is anything, then you need to monitor and you need to operate and maintain it. And end of cybersecurity support and decommissioning, right? So it is not just like that. Okay, I'm not using my car. Okay, I will make it crash. But they might be some of the issues which is not decommissioning. But still, some of the hackers can take the architecture about particular OEM and they can try to do the reverse engineer and they can try to attack the current vehicles. It can be possible. So that is why you need to have very clear recommendations and the support, exactly how long you want to support your vehicle along with the OEM and the tier ones, and what are the different decommissioning with respect to the hardware and the software you want to destroy the user data and also the software and the hardware, how you want to going to do. So that is the 14th clause. 15th clause related to the threat analysis and assessment methods. First, once you identify your item definition, we'll be identifying your asset identifications. Then for every asset, you need to think about the what is the different scenarios, threat scenarios I can identify. And what is the impact of it? What can go wrong, right? What is that impact analysis you need to do? And to make this scenario to happen, what is my attack analysis? Either I can enter through the cellular communication. Either I can enter to the OBD communication, or I can enter to your USB communication. What is that attack path? How a hacker can reach to the data, right? That analysis has to happen. And not only the analysis, and you need to be very practical, how it is feasible. For example, there is a sub-node network, sub-node ECU, which is having some data, right? But it doesn't mean that the hacker will not attack it, but we need to see the feasibility. He has to route through the T-box, telematic box, or the infotainment unit, what you are having, head unit, or IPC cluster, or the OBD. These are the different entry points. After that, in the latest architectures, we are having gateway as well, right? So they need to pass through the gateway. Then they need to pass through the network node, then the sub network node. So this is what is the feasibility we need to perform on this particular attack path, and understand, is it really can be hacked? If it is hacking, also what is the data that it is leaking out? Is it very important, right? With respect to the user, with respect to the vehicle, with respect to the OEM, with respect to the tier 1. And what is the impact of that particular data manipulation? So that attack feasibility you need to perform at this rate. And you need to have the risk value determination based upon some standards, right? And at the last, you need to have the, what is the treatment that I want to give for this particular risk, right? Either I can do some mitigation, I can prepare some goals, okay, to mitigate. For example, for the CAN communication, we can say that SecOC, secure your communication, okay, by keeping some MAC values, by keeping some freshness values inside your data bytes, and validate when point A to point B if I'm transferring some messages, right? So, and you such a kind of mitigations you can keep it. And you can see the JTAG, right? You can remove the JTAG after the at the time of production, because after the production you are having the updates through the FOTA and updates through the OBD. There is no point of having a JTAG which is just live like that, because it is one of the vulnerability, one of the attack vector if we are just living like that. So you need to take a mitigation action that you need to entirely remove from the PCB itself at the time of end of the line, at the time of production of your particular ECU, right? This is how is the recommendations are. And you can go through 155 at annexure. There are some couple of recommendations, which is recommendations only, because 21434 is also a highly a recommendation, but 155 there is a recommendations. What are the different attacks that you can perform on the car? What are the different vulnerabilities, and what are the different measures it is given, right? So yeah, this is what 21434 will tell, and what are the different clauses, and which clause is for whom, OEM, tier 1 and the tier 2s, and how we want to do it. So I recommend you all, please read very, very carefully the CIA document, which is expected from your counterparts, and read them and understand very clearly what exactly you want to do in this project, and what are the output artifacts. The output artifacts are named as work packages. For example, you can see here 10th chapter WP 10-6-7 will talk about the integration and verification activities, right? Which will be, you need to provide your unit testing reports, you need to provide your MISRA reports, static analysis, you need to provide your dynamic analysis reports, and you need to provide your fuzz analysis, you need to provide your penetration testing at component level, right? So these are the things that where it is recommended in the standard of ISO 21434. Okay. So, okay, at last, all the story is okay, but what is for me, right? So for you, it is enabled. There are a lot of jobs now because this topic is very hot. And your motto to be not getting a job, right? You should be able to contribute to automotive cybersecurity and secure the future car. That should be the motto, not getting a job. So the person who wants to be in automotive cybersecurity, right? The motto should be this statement, not the job, right? And I have just lived about some of the references from the Google. You can go through them so that it will help you to understand much more better about the cybersecurity of automotive. Okay, so with this, I just want to tell that I'm end of the presentation. And if you're having any questions, I can take it up, and you can be in contact with my LinkedIn. Okay, so if you like to, yeah, thank you. That's all from my side. Open for the questions.
Hey, thank you, Ishwar. Actually, I had a list of questions. You solved it in the last slide.
Okay. Yeah, we can take up the questions, please.
Yeah.
Yeah.
Ishwar, one quick question from my side, just trying to kind of understand from what you say. See, my car is an independent entity. Okay, so how is that when a system is being when a particular system is being somewhere across the globe, how is my car subjected to security threat? So how is that being connected physically?
I couldn't follow you. Could you please repeat?
No, you were mentioning about you cannot be secure and as an independent entity. When there's a particular system, there's a hack that is happening across the globe somewhere. Okay, then even our system is also like say subject to that security threat. Correct.
Exactly.
So
Yes.
Can you just throw a little bit of light on that? I'm just not able to digest that piece.
Sure. Definitely. So if we see, because we are using the similar kind of hardwares, even though it is a different OEM, different E&E systems, right? But we are using the similar kind of hardware.
Okay.
And the hardware and the embedded, irrespective of the functionality, it will work in the similar way, right? If I am able to manipulate some of the braking signals, right, with respect to particular architecture. So I can do the same thing with respect to the similar architecture with the similar OEM, with a different OEM, correct? So it will be always a threat, right?
Okay.
So that is why we are having a monitoring functionalities inside the standard as well. You need to always cross verify with respect to the public forums and with respect to the private forums, where you need to always get the information about the different hackings, how it is happening inside the world, right? You cannot be waiting for your car to get hacked, correct? You should be always secure.
Got it.
Yeah. Any other question?
Yeah, good afternoon, Ishwar. I'm Santosh.
Hi, Santosh.
As we have been mentioning regarding this gateway, so whatever, if you're having any updates or regarding any security, so the gateway you are mentioning about, so what sort of validations will be taken care within the gateway? Can you please
validation related to the first testing and validation related to the penetration testing based upon your attack paths, which you have mentioned in your TARA activities, right? So in your TARA activity, when you are doing, so you will be keeping on identify the asset, and you will be for that particular asset, you will be analyzing what are the different ways can attacker can attack this particular asset, and what are the different vulnerabilities for this particular asset, what we are having currently known vulnerabilities, and how I am mitigating them, what are the mitigation actions that I have taken in place. And you need to verify them as part of your verification and validation testing. or penetration testing activity.
Yeah, thank you very much. And actually, I have one more question.
Yeah,
As we have been discussing regarding this FOTA as well as OTA, so as cybersecurity and software update, both it will be a different parameters actually. If you could see, so how the again we will be continuously monitoring those two.
Yeah. Okay. So FOTA is for example, FOTA as a concept, it is just a wirelessly placing the images from point A to point B, right? But there will be always a hacker in between who can want to modify the data, right? So how securely you are transferring the data from point A to point B, right? That matters a lot for the FOTA activity. So from your cloud to the vehicle.
Yeah, maybe from more from the centralized servers to the and providing the more and more encryption with the data which we are going to send to the vehicle.
Exactly,
So
exactly. Not only the one-way traffic, so there will be a two-way traffic around. From vehicle also is sending a data to the OEM cloud.
Yeah, will be acknowledgement will be received from the vehicle also.
Exactly. Not only the acknowledgement, there are a lot of other data which will be exchanged. So that data also needs to be protected safely.
I have one more thought. I'm sorry if
Carry on.
Yeah, if suppose we have been updated through OTA, and suppose is there any restoring point will be available that such that I can go back to the older versions of the software which is existed?
Yeah, it is all depends upon the OEM architecture, how they want to define about these particular updations, right? So there could be a lot of other challenges related to the embedded, like they may not be having a sufficient memory. They may be having a sufficient memory, but not sufficient time. So there are a lot of other parameters. What OEM has to think about each and every ECU, and they need to come up with the strategy.
Yeah, does we have any implementation in such a way?
Of course, there are a couple of implementations already available. Like you can say the parallel boot mechanism and parallel image mechanism and all activities are available as a solution.
Yeah, okay. Thank you very much. Thank you.
Yeah, thank you, Santosh. Yeah. Yeah, Abdul. Yeah, please go ahead. Hello, I'm unable to hear you. If you are speaking.
Abdul, I think you are on mute if you are speaking.
Yeah.
No. He's having some challenges, it seems to.
Oh, okay. Can you help him, Bhishma?
Atul, can you type in the chat window?
Yeah, we know you can continue. Meanwhile, we can solve the Atul's. Please elaborate on safety issues and your telematic box. Okay. So, okay, Vinod, 1 minute. I have the question here. So, yeah, safety issues with respect to your steering ECUs and braking ECUs, which will leads to the human damage, right? So such kind of ECUs, you need to not only the safety, but you need to have the security as well, right? So in my opinion, security is dominating than the safety, because if we see the ECUs, safety ECUs are very less, but security you need to provide almost all for all the ECUs which you want to do the updates over there, right? So I can say that now it is becoming much more relevance about the security than the safety, but we cannot neglect the safety. But safety will come after your security. Because when you want to secure, then only the data will be valid. When the data is valid, then you are safe. And telematics box, because you are having a lot of open vulnerabilities and the assets, I can say. You are having Wi-Fi, you are having your Bluetooth, you are having your USB ports, you are having your jock, physical, right? So you are having your eSIMs, right? You are talking to a, your vehicle is trackable, right? All these are the different assets where they will be having a lot of vulnerabilities for each and every asset with respect to the telematics boxes, right? So that is where you need to have very, very rugged and concrete measures to mitigate, because they are the entry points. They are like your home main door, right? When your home main door is weak, then it is very hard to they can easily grab your items, right? So that is how it is. Yeah, we can take other question. Karthik, someone has raised the question hand, correct?
Yeah, I'm just trying to. Hello?
Hello, yeah, please.
I think the question is on the chat window, Ishwar.
Chat window. It is Atul again.
Yeah.
ISO 21434 clauses specified are in sequence. No, it is not about the sequence. It is, if we listen carefully, it is the mixture of the OEM and the tier 1 programs. It is not about the sequence. Okay, any other question?
Yeah, hi Ishwar. This is Sheetal here. Yeah,
Hi,
I have
Sheetal.
one question.
Yeah, please.
Means we have many devices which are connected using CAN to the network in the vehicle.
Yeah,
so
network,
those are also will be covered in the cybersecurity, because most of the things are covering the wireless network, quota,
no,
and other
not
things.
see, wireless network is only the entry point. Once you have entered into the T box, from T box to the other systems, it is a network, correct? It is network through your CAN bus, or there could be a Ethernet, or there could be a LIN, but everything it is interconnected. Right? So there is a chances of manipulating the data of any issue. The only thing is the hacker should be very smart enough, and he should know in and out of the embedded systems and the automotive, how to figure it out to reach to a particular place.
Okay.
Yes.
Okay, yeah, thank you.
Yes, Sheetal. Yeah, Atul. Atul, we are unable to hear your voice, but I can see the chart. Last one. What should be cybersecurity properties for an asset? See, any asset, right? You need to follow the standard of a CIA, right? Then you need to question by yourself. CIA about particular asset, then you need, that is the starting point. As a fresher in automotive testing, Vinod. Okay, as a fresher in automotive testing, how the OEM will code the ECUs, what type of program language are used, and how freshers should start. Okay, yeah, for the freshers, I can say that, okay, for the related to the testing activity, right? So first thing is you should have the interest, number one. And number two, the coding programming languages are C, C++. And if you come to the application kind of thing with respect to the entertainment and your infotainment, so there are C++ and Java and your Android applications and all. But predominantly apart from your telematic box and the infotainment, all other issues is into C and C++. Okay, how freshers should start? So freshers can start. First thing is I was telling about the interest. Number one, just don't read the documents. You want to practice inside cybersecurity and the other areas of automotive. If you know the concept, if you are able to confidently tell about the concept about your interviewer or in the automotive, you can able to do it, but not that is not the true with respect to cybersecurity. Cybersecurity, you should have the hands-on experience. Then only it is worth to sustain in the job, not getting a job. Getting a job is depending upon your interviewer. If you are able to convince your interviewer, you will get a job. But you cannot sustain the job as part of the testing activity, because you need to do the first testing, you need to do the penetration testing activity. You should know in and out of the hardware and the software, how your embedded systems will work. So such skills you should have it, and you should have hardware knowledge as well, and you should have the debugging skills. So as an embedded engineer who is very strong at the basics, he can do with respect to the testing concepts, he can able to perform in my view. So freshers can, there are a lot of YouTube videos and there are a lot of material. See, nowadays information is not lagging. It is only lagging is commitment and the consistency. That is the lagging from the person. Information is everywhere. Even I was just saw that the standard of 21434 is publicly Google. If you are typing ISO 21434, you will get the standard itself. So information is available, but only thing is how strong you are committed, how consistently you are there, then only the success will be there. Yeah. Okay, anything else?
Thank you, Ishwar. I think we'll take this. If there are any questions, please reach out to Ishwar directly. He has shared his email ID and LinkedIn profile. Please do connect with him and write to your questions. Thank you, Ishwar. Thank you so much for your time.
Thank you all for interest showing to this session, and thanks for your participation. Thanks for ANCIT for recommending me to be part of your journey. Thank you. Thanks a lot.
Thank you, Ishwar. Thank you so much. Thank you so much for sharing your experience on cybersecurity, and more importantly, bringing a lot of hands-on experience and also leaving us with a note where to start and how do we proceed in our journey in cybersecurity. Yeah. Thank you so much for your time.
Thank you. Thanks a lot. Yeah.
Thank you.
Bye.
Friends, we'll have a quick lunch break and we'll recollect again at 2 o'clock for our next session. It is going to be very exciting. It is going to be a complete hands-on on how to use the EV Tresos tool for automotive AUTOSAR development. Okay, so we have two experienced engineers from Elektrobit who will be running us through this whole two exercises. We look forward to connect with you at 2 o'clock. Please stay tuned. Thank you.
Thanks.
The recording has stopped.
Hello Sivaram and hello Srikanth. Thanks for joining.
Hi. Hello all. Hello.
Shall we start the session, Sivaram and Srikanth?
Yeah, if we can start.
Yeah. Before that, let me give you a quick introduction about you both to all the audience. So welcome back all to our afternoon session of this Automotive Tech Day. So in the afternoon session, we have the demonstration of the EB Tresos tool by Mr. Sivaram Nagarajan and Mr. Srikanth Kumar BS. They are both from Elektrobit. And Srikanth Kumar BS is a technical architect who is having 12 plus years of experience in the industry. He is well versed in driver development of embedded firmware, powertrain, infotainment, and AUTOSAR. He has worked in a number of countries, Germany, South Korea, and now he is working in India. Currently, he is the part of Infrastructure Services Department in Elektrobit India Private Limited. Srikanth has a degree in electrical and communication engineering. His expertise lies in developing AUTOSAR compliant systems and embedded firmware. And our another speaker is Mr. Sivaraman Nagarajan. He is a senior technical specialist from Elektrobit. Sivaraman also comes with a vast 9+ years of experience in the industry. He is well versed in driver development of embedded firmware, powertrain, and AUTOSAR. Currently, he is part of the Infrastructure Services Department in EB. Sivaram has a bachelor degree in Electronics and Communication Engineering. His expertise lies in developing AUTOSAR compliant systems and embedded firmware. Thanks for joining both. So can we start the session, Sivaraman and Srikanth?
Yeah. Thank you. Thanks for the intro. Maybe I'll start. Share my screen.
Yeah, please.
Okay.
Yes, the screen is visible.
Okay, let me turn on the video also. 1 second. Okay. Hello all. Let me start the meeting. Okay, so is the slides visible?
Yeah. Both the slides also visible and
okay.
Your video also visible.
Okay, so hello all. Let's start. Okay, so today in this session, I'll set the context. What are we gonna deal? Mainly the session will be giving an insight into the classic AutoSAR platform and the Tresos as a tool to implement classic AutoSAR platform for different use cases and different projects. So that would be the idea, and the session would be into 2 parts. One where I'll be first explaining regarding the AutoSAR and stuff, and also regarding the usage of Tresos and the various features in Tresos. And second part will have the demo, wherein my colleague Srikanth will be presenting you a live demo of how to handle Tresos and what are all the features present as part of Tresos. And we will proceed to the questions from there. So this is how the session would be, and this session would mainly be processed for classic AutoSAR topics. Okay, and if you have any questions, you can put it in the chat, and also we can take it up in the last part after completion of the demo as well. Okay. So first, with respect to EB Tresos, we'll just go into that. Before that, So I just want to give a glimpse. Maybe see some of the content that we are discussing might be redundant for you. You might have already been aware with complete AutoSAR topics, and also some might have used Tresos as well. Yeah, but yeah, some might be redundant, some might be new to you. So I'll just run through them. So basically, what we are trying to do as part of AutoSAR here is going into different domains, right? So as a part of a vehicle with increased complex architectures, we need to involve more and more software into the vehicle. And there are some domains which majorly have certain ECUs which are which require us to develop softwares, and some of which are mentioned here. When you take it an interior domain or a powertrain domain or a body domain, so all these use cases requires complex software architectures, and that has to be simplified or organized in a platform, in an architecture that has to be used across OEMs and suppliers, right? So that's where AutoSAR comes into picture, and that's where EB comes into the picture as well. So EB provides this AutoSAR software for implementation of complex architectures as per AutoSAR guidelines. Okay, just to give a glimpse again regarding how the legacy code is and how we are gonna move it into the AutoSAR compliance systems. So mainly AutoSAR came into picture for interacting, the software being more interactive with hardware and also being independent with respect to hardware. So what we have come up with by using AutoSAR is a more layered architecture. So what used to be your unorganized or unlayered software architecture, wherein we will be able to directly access the hardware drivers, and the functionalities will be able to be accessed from one point of the software to the other point, is all organized in terms of different layers. So this layered architecture is what AutoSAR is all about, and yeah, you might be already knowing about this. So apart from that, as part of AutoSAR, we are also supporting the different vehicle networks like protocols like CAN, Ethernet, CAN-FD, FlexRail-in, etc. So AutoSAR helps us in having a more structured, layered architecture, and thereby supporting different communication protocols. And also you can have a more microcontroller independent software. So that's where the major role of AutoSAR comes into picture. So we'll dig deep into the modules as well. That also we'll see in the next slides. So since our topic today is mostly with respect to Tresos product line, so I'm just gonna run through different product we have as part of Tresos stack. So Tresos, you might be already aware, is the complete product line of Classic AutoSAR from EB's side, and Tresos Studio is the base software configuration tool. This is an Eclipse-based tool wherein all the configuration of the base software modules can be carried out, and we have the modules developed for different use cases as well. So our complete base software, which is responsible for let's say a COM stack or a memory stack or security stack, all put together is called as EB Tresos Auto Core. This auto core is what is being implemented and used for different OEMs and tier 1s for their application software development also. Then we have the safety products. So depending on the requirements for the OEMs and tier 1s and what ASIL level they want to achieve, our safety products also are provided, wherein their further application development and base software configurations should adhere to the ISO 26262 standards based on our safety products. So we have safety OS, safety RTE, safety ETE, and also safety time E, which are all the different products that can be used to implement the safety standards. And safety OS, I have already mentioned, and AutoCore OS is a non-safety OS which can be used for both single and multi-core operating systems as well. Then bootloader, we also offer bootloader for different OEMs based on the requirements which has been specified by the OEMs. So this bootloader again will be used for your reprogramming sequence and so on. Okay, so now coming to the use case of our base software or AutoSAR based software in general, the main idea with respect to AutoSAR is to have more reusability and more structured way of implementing the software, right? So with respect to the AutoCore that we offer as part of EB Tresos product line, our softwares are capable to be adapted for customer specific requirements. We already supporting all the major OEMs OEM specific modules, and if there are any new requirements being specified, that also can be adapted for adapted in the AutoCore itself. So that's one major advantage with respect to our AutoCore as such. And yeah, you can extend in such a way that the modules can be grouped together and then reused according to the use cases and also for the applications. You can reuse it from one ECU to the another ECU based on the use cases. So apart from that, our AutoCore goes into different applications. It can be a body control or a ADAS ECU or even a powertrain ECU. It can be used for various applications and also for various communication protocols. And our safety products goes hand in hand with the already existing application and also with our base software. And our products are also all qualified for series productions, and it can be used for any customizable requirements also, which are not already covered by AutoSAR. For example, Jasper, you might have had a session with respect to security before, right? So this with respect to security, majority of the push is coming from Jasper standards. We are just trying to adapt, and EB also is taking over from some of the contents from Jasper. So likewise, if there are any requirements which are not compliant with AutoSAR, that can also be covered by using the AutoCore. Okay, so this comes the complete picture of the modules which are present in a AutoSAR compliant ECU. So Studio is nothing but our configuration tool. So our Studio supports in developing a software which can be legacy code also. So when you are migrating from a legacy code to the AutoCore or AutoSAR compliant software, you can use the already existing DBCs or LDF formats, whatever. This all can be imported into the Tresos, and then further configurations can be made. And of course, ARXML is also supported. And as part of after configuration, if you want to export and then share it with another supplier or another OEM, that is also supported as part of Tresos. Then we also have the major features of Tresos is with respect to base software configuration and source code generation for the modules, base software modules. And apart from that, you will be able to do system signal mappings, port mappings. Anything with respect to base software can be achieved via the Tresos. And here you can see with respect to architecture, you are already aware, with respect to a COM stack or a mode management or diagnostic stack, all the modules which are defined by AutoSAR are provided as part of our AutoCore package, and this can be used for seamless integration into the projects. Okay, so now coming to OS. So our OS, which are now with high performance computing coming into the picture, we are in requirement of having a technology that will be able to combine multiple use cases, right? Like our computation needs are increasing day and day, and like with single core, you will not be able to achieve all those things. And now comes all high performance controllers, which can have multiple cores, and our operating systems are aligned to such architectures from different MCAL vendors as well. So we'll be able to handhold both classic and adaptive AutoSAR as well in our system. And our AutoCore OS and Safety OS are already supporting the multi-core ECUs, and it can scale up to ASIL D safety level as well. So that's a major point with respect to our AutoCore implementation, because we can scale up our ECUs until ASIL-D also. So with respect to tool, again, EB Tresos, just to give you an idea, EB Tresos, yeah, it's a PC-based tool, and our code generation will be based on the configurations that can be done. And for supporting the configurations, there are different kinds of assistants that are present as part of Tresos. There will be a set of wizards, there will be some workflows which will help you in configuring the base software modules in an easier manner. So these all are present with respect to Tresos, and when Srikanth touch bases upon the tool demo, he'll be able to show you some of the use cases of some of the wizards and how workflows can be used to do the configurations also. Okay, and then comes majorly with respect to generation. We will be able to complete the RTE based configurations as well, and you will be able to have a template files for your application. So all your RTE related APIs will get generated by Tresos itself, and from there you can do the hand coding for your application by taking it over, and then you either hand code or model based coding can be done for the application development as well. Okay, so now with respect to features of our tooling environment, we support both AutoCore as well as the OSEC core. Our Tresos Studio will be able to support both the cases, and it is easier to migrate for any make tool chains, or if you want to have continuous builds. All this can be achieved with our existing tool environment itself. And like I was mentioning already, you can have OEM specific modules which can be integrated or updated by using our Tresos itself. And you might be already aware, some of you might have used Tresos for MCAL configurations. There are some vendors who use Tresos to develop their MCAL modules as well. So that way it becomes easier when it comes to migrating MCAL and the base software together also. Okay, with respect to flexibility, like I was mentioning, there are a lot of wizards and workflows, and we also support the command line interface. Thereby, you can just merge it for continuous build activities as well. So these all are different features that are present with respect to our EB Tresos tooling environment. So this is just to give a glimpse of our product and what it can do before you get into the demo. So just an idea regarding how AutoSAR as such is being implemented using Tresos. Maybe some of you might have already known some contents and also had used Tresos, but now Srikanth will take you into the demo part. Maybe post that we can also take up some questions with respect to the tool. Okay. Srikanth, would you like to take over?
Yes. Thank you, Sivaram. Thanks for
the
introduction on the EB Tresos Studio. Let me share my screen. Kindly let me know once you see the screen.
Yeah, okay.
Thank you. Okay, so when you download the package EB Tresos from us, then these are the basic folders that will be present. Yeah, so this is where we will be now looking into more in deep. So to start with, let's go to EB Tresos Studio. Once you open, so if it is a new new package that you are going to install, it will check for the directory workspace. So basically where exactly your workspace, where you want to create your workspace for the projects. Yeah, so this is where we will be starting with. And once the loading is done, so you would see this welcome window. So in this welcome window, let us now understand each of these blocks before we go into the Tresos Studio itself, before we start with the project. Yeah, so here What's new is basically the information that is, it contains a document that provides the information about what changes have been done from the previous releases. So it does not give you the complete information, but only some special attention that is required from the customer's perspective is what will be provided. Sorry, just a moment. Release notes. So this gives about the what are the fixed problems, what are the problems that have been fixed in this version, and what are the features. And the support request basically will open, it's a link to our EB support page where you could, if you need some information or you're facing some issues, then you could reach out to us via this support request. And the help is basically for you to understand how to use EB Tresos Studio. So this would open a document which would help you to understand how to use if you're a first time user of EB Tresos Studio. Okay, and the training. So this links to the EB Automotive technology training courses. So you could request for the trainings, what is required, for using the EB Tresos Studio. And then the last, so this basically closes the welcome, and then you would be able to see our Tresos Studio. Yeah, so here we have different views. Before we go into how do we create a project, how do we create a, we first let us understand on these views what is available, and then it would be easier for you on the upcoming slide, the demo. So basically, this is the Project Explorer. So this view, it displays all the EB Tresos Studio configuration projects. Okay, you can create the projects in the workspace. So in this case, my workspace is under this path, so I can create the configuration project here. So where you could edit the project and then open multiple editors. Next comes the outline. So here, this outline will give us the tree view of the editable configuration parameters. Then the workflows. So this workflow is basically kind of a guide for a new, when you are starting newly. So it will help you to accomplish certain task. So this will give you some information on how do I, when I start a project, how do I have to start a project, and how do I have to use the importers? How do I have to, we have wizards, unattended wizards that I will touch upon in the later part. And how do I do the, how do I configure the AUTOSAR modules? So all this information is provided in the workflow. Next, most important, or let's say interesting part, would be this sidebar. So here, this sidebar will basically give you an assistance dialog for your current task. For example, if you have a memory stack and you want to configure the memory stack modules, so here you would see basically the in the sidebar where that could kind of configure. So you can configure in one, let's say in NVM, and that would be already updated for the below modules. So that is the main purpose of this sidebar. Next comes the error log. Yeah, as you see, this error log is for where errors are logged. So in my case, I did not connect to VPN, so I had a license issue because I had not, I don't have the node specific license. So that's the reason I have got the error here. And problem view is basically the place where you can see the messages with respect to your configuration of the loaded project. That means if there is any warning or if there is any configuration issues, so those will be, you could see here. Yeah. And last, the properties view is basically to give you the information about the selected parameters in the generic editor. Basically, this is the generic editor where you could open the modules. So to start with, so let's create a project. And for creating a project, there are two types. One is to create a project from the start, from the scratch. And the second one is to use template based for the creation. Now let's start with the project from the scratch. Yeah, for that, what you have to do is go to File, go to New, go to Configuration Project. So here you can give your any project name, for example. Okay, and here it will say where exactly your project is going to be. Yeah, and then here the which AUTOSAR version you will be using it. So you can use any of this and then say next. So here basically this is the ECU ID what you can give, something like this. Okay, whatever your ECU is, and then the target. So in this demo I am showing with the tricore. So here the MCAL whatever is provided is being applicable for these derivatives. So let's take one of the derivatives. Okay, and here is the generation path where exactly you want to generate your configuration files. So you could give it, and these are something where you want to let's say if I want to have the minimum number of child, for example, if a module contains it says that it needs 2 child or 1 child parameter already present, so that can be automatically done. And this is for the config time support. For example, if you want to have a pre-compile or link or post build, that can be used. So once you see that, so these are the available modules that are from the BSW perspective. So which module you want to add it in your project. Yeah, these are the by default these modules would have already been added. Okay, these are some of the mandatory modules that is required for any project from the EV Tresos Studio perspective. Yeah, so you could add whatever module you need here, and then you will have the, let's say I have some pre-configuration that has to be used or recommended configuration that I want to use for a particular module, that will be, you can. So basically, let's say if I want to add one of the module, so I click on that module and then I say add it to my project. So on this part, you see what is the, you get the information about that particular module. For example, where exactly your configuration file is present and where the generation will be done of the configuration file and few details about the module. So please let me know if you have any doubt or if I'm going too fast. So you could. Sorry, I don't think if you raise your hand I will be able to see, but you might have to unmute and you would have to stop me. Yeah. So I hope this is clear.
Excuse me. Yeah, this is Prabhu from HCL Technologies.
Hi, Prabhu.
Yes. Hi. Here you have given that CAN stack. In that CAN, that is CAN IF, CAN SM, CAN TP, everything is there. Okay. So whether this this contains coding also?
What do you mean by coding?
No. The thing is, for example, if I need a CAN TP, okay. So in CAN stack you have the CAN TP, right?
Yes.
Whether that is integrated with code also, or just it's a module. That is. If we connect that module means, if we add this module means immediately that particular module will be activated. According to that, driver will be enabled or what?
No, this is only for the configuration. So this is the module configuration. So the for example, you will have a lot of editable parameters, right, for every module.
Okay.
So this module will be now you will be able to update or you could configure your module. I'll give you an I'll explain you in the upcoming.
Okay, fine. Okay. Yeah.
So as you see, so here you have either you can see based on the classification grouping, or you could also go to the all modules and then you could see the complete modules, whatever is been available. Yeah. And then once you add it, then once you say that, okay, these are the modules that are required for my project. So once you add it to your project, then you go to next. So here, this is an optional step. This can also be done once you create the project, but these are something called as importers or exporters. If I want to import an system ARXML file or software component ARXML file, so those you could add it here in this. Yeah? For now, we will just see. So if you see here, so this will be the project. Under that, this is my ECU name, and it will say which target and which derivative I'm going to use. And under this, you would see here the modules, whatever we have added. Yeah, and in Tresos, we always use the format called .xtm. So these are the XTM files. That is nothing but the configuration. Okay, this is one way of creating a project. Okay. The second way is, let me close this project so that I don't. The second type of creation of the project is from the template based. So to take a template based, what you have to do is you have to go to import and then existing project. You have to browse. So wherever your Tresos is installed, under that, you would see a template, and then under AutoCore, this is the ACG version. I think we could ignore as of now. So here you will see a basic template. So this is already a bare minimum project, yeah, where you could build upon this. So that is the main purpose, or let's say this is a template based. As you know, we already have something in this project. So most important, make sure that you enable this copy project into the workspace, because this is under templates, and you don't want to edit the template itself. So that's the reason why you always make sure that you are using in your workspace. So once you say finish, then now the project has been copied in my workspace, and you could always make a rename here. You could make it to your project. Something like this. Yeah. And then double click on this ECU. And now you could already see the modules that are added or are already present in this project. For example, BSWM or DM, DET, ECUM, MCU, RT, OS, like this. Yeah. So this is already a project where you could build it, generate it, and then you could compile, and then based on the compiler what you are going to use, and then flash it. And this software itself would be running on the hardware where the board is up, and then you could you can then extend with the modules that you want to add. Yeah, for example, let's see one of the configuration. So we'll go to OS. So here you see these are the the containers that would be configured. So we have as this is a template based, we already have two tasks. One is the init task for the initialization. The other one is the 20 millisecond cyclic task. So every 20 milliseconds it would be running. Yeah, so here, so you can also do the composition. That means when you have the system extract imported, and then you have the application software component RXML files or CDD RXML files, then you could do the connections, port connections in this editor. So here you could basically see how the workflow helps you. And as I mentioned, the problems view will be showcasing basically what are the warnings or if there is any configuration error that I have. Just to give you an just a demo. So for example, if I make it as 0, so the OS task activation minimum should be from 1 to 255, where I'm now giving as 0. So it will directly give me an error saying that, okay, this is an invalid value. So these are some of the examples. Okay, so this is about the demo. Now we could answer a few questions. I already see that we have one question that can we change ECU tri-core type also after project is created. No, this project is basically on this particular target. Now, if you have a different target, so that you will have to create it for a new project. Ensuring ideally you will have one TresOS project for one MCAL, one OS. So you will not have TresOS Studio for multiple targets, and multiple OS will not be possible.
Okay, then hello, can you hear me?
Yes.
Yeah, then during the creation using the basic template, then it is not possible to change it. No, it will be defaultly selected for the basic template project creation, right?
Yes, basically when we are providing the package, we also do the qualification for that particular target and the derivative. So if you're using for a different derivative, you will have to again requalify the software.
Okay. Thanks.
Yes. So this is about our EB TresOS Studio, and also we have something something called as unattended wizard, which can make your configuration more robust. Yeah, where you can also do the automation. Let's say I have certain parameters that I have imported from the extract, and I would like to I have to change that particular parameter value, and every time I cannot do a manual. So I could also make it in such a way that this will be part of my workflow. So within the workflow, I can make it as a part where it will automatically update that particular parameter. So these are some of the unattended wizards that are available within EB TresOS Studio. Yeah. With respect to the generate, so you could directly say that once you update it, you could do a generate. So this will now create .c and .h files, the configuration files under output. So any doubt? I think we are done with our demo.
Yeah, hi. This is Jeevan.
Hi, Jeevan.
Yeah. So whenever you develop a driver, suppose I take an example of CAN. So you need to configure a lot of registers, right? Baud rate registers and acceptance filters. And we have to place that content into transmit buffers. It might be interrupt based or time period based.
Correct.
And you get the information in the receive buffers, and you just see whether that is matching my ID or not, and then you receive the buffers. So correct. There might be a couple of functions, different functions, what we'll be writing at a device drivers level. But when it comes to a tool, how do we configure those, like the entire CAN?
Okay, for CAN, basically the MCAL will be provided by the silicon vendor. Yeah, so they already have this static code where they do the changes according to your configuration. For example, if I want to make my my CAN TX and RX as polling or interrupt, I will have a particular container where I could select. It's just like where you are entering, where you say that, okay, I want to now something like this, whether I want to OS task schedule as a full or none, something similar with respect to the polling and interrupt. Yeah, with respect to the baud rate, you will have the container itself where you will have to put what is your what baud rate you would like to run, and what are the the concerned variables that you will have to update it. So you will just have to update these things, and the MCAL itself, the static code itself, will take this as the parameter, and then it will do the setting. For the CAN buffer, so we also have in the as I mentioned, the sidebar. So here we have the CAN buffer assignment, where you can assign for the messages what type of CAN you would like to use, and then whether it's a basic CAN, whether it's a full CAN, which hardware object you would like to configure for that particular CAN. So that's how it will be.
Okay, yeah, thank you. And one more thing is, like, say, suppose different teams will be working on different modules. So one might be configuring CAN, and other might be configuring some PWMs or some other things. How do we integrate these two? Because ultimately, there should be one hex file going into the ECU.
Correct. So you mean that unless it is, let's say, there is no conflict. For example, if I'm doing for the COM or for MEM, if I'm not touching RT, it is still fine, because you could directly take the XTM and then you could integrate it. You can use it. You just have to create it. So that should not be an issue. But when it comes to RT, that is where the complexity happens. So one has to take the XTM and then do a workflow. So that is the reason why we have this workflow, which will help you to get rid of some ambiguities. Did I answer your question?
Yeah, but how do we integrate? Integrate is what I'm asking.
Yeah.
See,
so
yeah.
So basically, if you are working, if you're working, let's say, if two people are working on different stacks, so it is absolutely possible. So you could just do it on your part. On let's say I'm working on a BSW, yeah, and you're working on, let's say, ECM. Yeah, I will do my configuration here. So that becomes kind of the strategy within the team or within the project, how they would like to do the integration. Yeah. So from the tool perspective, there is nothing as such. Okay, I can do I want to do a split and then I want to merge. There is nothing as such. So it will be like a project, and whoever is working, so they will take that base and they will start working. Yeah, it's like any other project.
Okay. Thank you. And how do, like, once the code is generated, how do it look like? Can I just any example of?
Sorry.
So once we have to generate a code, right, from this configurator. Yes. So how do we generate a code?
Yeah. So basically, there are two possibilities. You either generate for the complete project, or you could also generate the configuration for a particular module. So in my case, now what I have done is I have now generated for the entire project. So if you could see here, there is the include files, yeah, and then the source files for the modules that are available here. So this is how it will be generated. So with the extension of underscore CFG or LCFG or PBCFG, depending on what is the.
Okay, fine. Yeah, thank you.
Yes. Any further questions?
Hi, Srikanth. I'm Santosh.
Hi, Santosh.
See, when we are using a template approach, right? Is there anything we need to configure with the modules, or it's readily available everything? So
No. This is only a template. So that means this is the bare minimum. So on this template, you can start adding your module. So this template, what we have now got it, right? It is bare minimum. So you don't have, let's say, I don't know whether my project is on CAN or LIN or FlexRay or Ethernet. So those information is not there. This is only kind of a base where upon this you can start building. Upon this you can start adding the modules, importing the extracts, and then configuring the modules, and then the generation like this.
Okay. Do we have any limitations on the using the template, or still it is okay? We can work on this base module only.
Yeah, absolutely. There is as such nothing implications, or there is no as such side effects unless you have very specific for your project. Yeah, because basically in this template based, you would already get some integration codes. Yeah, the basic working, because this template is already it's a flashable software with bare minimum. So where you have two OS tasks that will be running on the hardware. So this is something like very minimum.
Okay.
Using this, you can extend it, or you can, let's say, I don't want to use template, I want to create my own project, then you could always do it the first way.
Manually, yeah.
Yes.
To exclude the exceptions will be there, so we can go with the manual thing.
Yep. Yes.
Yeah.
So it's up to the user, customer, how they want to use it.
Okay, fine. Thank you.
No problem.
Hello.
Hi.
Hi, Srikanth. This is Dharni again. Is there any complexity? Hello. Am I audible?
Yes.
Yeah. So till now, is there any complexity has happened between the generation? Like what I was asking is like, is there any possibility in the errors? What are the errors that we might be facing during this?
Yeah, it depends really, completely on the project. How complex is the ECU extract? What are the features that are being, from the AUTOSAR? What features are being used? So something in general, what we see is the customers will have, they try to take more time in the RT generation. Yeah. So this is something not with our EV tool, but as a in general. In general, with respect to the AUTOSAR, so RT is something which is very complex.
Yeah, so then till now, the module creation also been between the two ECUs also when generating or taking up this, we haven't faced any of the issues in this.
First thing is this will be applicable only for one particular project. So my one project in the workspace represents one ECU.
Okay.
So I cannot have multiple ECUs under one project.
Okay.
Yeah. So if it is let's say I have this as ECU1 and this as ECU2, so that will be two different projects. There is no relation between 1 and 2. I mean to say with respect to the configuration perspective.
Yes. Thank you.
Okay, one more question. We can generate code using the MATLAB models. So should we integrate that models into this configurator, or the code generated from the models, and how do we integrate these two?
This will be very specific based on the project requirements. First thing, the models cannot be directly included in the EB Tresos Studio.
Okay.
So if, for example, you are creating a CDD, then unless it has any connection with the RT, so you could directly integrate as a .c and .h file, and then you could do it. If it is an AUTOSAR, how AUTOSAR says for the CDD development, then you would have to have the ARXML files that has to be imported, and then you would be able to integrate it. But the models itself is not possible.
Okay, thank you.
After creating, this is Bala. After creating the project, can we delete or insert any of the modules?
Yes. You can absolutely. You can go to the module configuration once you create the project. Now, let's say I have just created a template. Now you could add, or maybe I can also delete it. Yeah, you will say that, okay, this, as you see, let me not take this part just to. Yeah, so you could say that, okay, you want to delete the XTM itself, or you just want to remove this module. And at the same time, you could also say like, okay, maybe now I don't want to delete, I don't want to use it, but later I will be able to use it. You could just say that, okay, I don't want to enable. And then you should be able to see that this will be grayed out. So that means this module is now you will not be able to generate.
Okay.
You cannot use it. Yeah, this is a great one.
Okay. Can we reuse that model into any other ECU projects?
If it is the same version, yes, you can directly go to the config. You can copy this file in that particular workspace, and you could use it. But if it is a different version, then it will not be possible.
Okay.
There could be some changes. I would not say not possible, but you would have to ensure that it is working as expected.
Okay.
Yeah, hi Srikanth, Manjunath here.
Hey, Manjunath.
I have a question on the simulation part. So once we kind of configure and generate the code, so this Tresos supports any kind of a simulation without even flashing on the board. Can we run this modules?
Unfortunately, no. Okay. Because the simulation part, or let's say the compilation, or how you gonna use it, is purely on the customer. What they are using. That's I think if you had like Sivaram explained that we do only the generation. Customer will be able to use on their make environment. So our tool provides that flexibility to integrate. Let's say I want to build on some continuous integration system, so my Tresos will be able to support that. I could generate it, I could do the workflow, I can basically import everything. Whatever I can do manually, that will be possible in continuous integration.
So if I have to say, EB Tresos responsibility ends once the .c and .h are generated, but there are some add-on command line supports where you can use the tool itself to compile and build.
Yes. So here in our scenario, we also have the make, as you see here. So we could build it, but again, this is very much specific to our build environment.
Understood. Generic,
yes.
Not specific to the
not specific to any of the OEM.
Okay. And just wanted to understand the license model. So how does it work? The EB Tresos license, do we have a full-fledged license, demo licenses, something to try out for the beginners?
Yes, we do have the demo license. Maybe you can just go to our EB webpage, and there you could request for the license, where we provide the demo license, where you could try these things. Like it will be like full-fledged, where you could try your hands on the tool. you could explore more. This is available. Yes.
Okay.
Thanks.
Yes.
Yeah, the code generated, is it like the MISRA compliance kind of thing, or is there any option we have to select that should be a compliance?
No, it is already MISRA compliant. But let's say if you are developing a module and you want to integrate in EB Tresos Studio, there is also possibility where you could check whether if that module also is compliant to MISRA. That is possible.
Yeah, thank you.
Is there any more questions? Srikanth, I think there is no more questions.
Okay, thanks. Thanks a lot. Thanks for your questions. I hope you were able to understand.
Srikanth and Sivaram, for your wonderful session on EB Tresos demonstration.
Yeah, thank you all, and thank you, ANCIT.
Yeah, sure. Thank you. So, dear participants, next in our event, we have one more exciting session. The speaker is Mr. Nisarg Nirmal Kumar. He is the CEO of Skillicon. Basically, he is a techno-commercial consultant. He is a founder and CEO of Skillicon, and he is also a former sales manager in RA Consulting GmbH. He was a visiting lecturer in Hochschule Heilbronn, and he also a ex-Boschler. So welcome Nisarg for this wonderful event.
Thank you, Bhishma, and hi everybody. Good afternoon. So my introduction has already been given by Bhishma, and the topic that I'll be speaking about today is a deep dive into CAN and diagnostics on vehicles. So to decide on what is the depth or what is the basics that I have to speak about, I would like to understand how many people here are, freshers or who are looking at CAN and diagnostics for the first time, or how much are you experienced with CAN and diagnostics? Bhishma, can you help me with this information?
Yes, so the participants can unmute and update newer to CAN.
Just this, are there any freshers? Can you please?
Yeah, you can raise your hands alone. Okay. 3, 4.
For freshers?
5, 6.
5, 6.
7, 8.
Great.
Nisarg, we have 15
so
out
15.
of 80.
Right. So that's a good number of freshers. I think
yeah.
I'll mix my session into. There are more than 15. So
yeah.
So let me mix it with. Let me start with basics, and then I'll also go towards a deep dive into these topics. Okay. So what I'm going to do now is I will start my presentation and then share my screen. So there you go. Are you able to see my screen?
Yes, Nisarg.
All right. Great. So what I'm going to start with is first to explain what is in-vehicle network. So why it is needed and how it came into existence. Yeah, I'll go a little bit fast with basics so I can also cover more topics. So I'll skip this part. So let's talk about features of a modern car. Yeah, if you see, we need fuel economy, we need lower emissions, we need airbags, infotainment system, small but powerful engine, parking assist, steering controls, cruise controls. Yeah. If we ask someone what is that you want in your new car, it will be all about these kind of features. And it's no longer about nuts and bolts. Nobody cares about it. Nobody touches and feels about it. All we want is new super modern technology. Yeah. And to achieve all this, it's not possible with just mechanical system. That's where a lot of electronics came into picture. And that's how probably you would have heard about it, the ECUs, electronic control unit. You would be introduced to these things. So what happens is, let's look at few features of the vehicle in detail. So functions of a car, wherein we'll discuss about powertrain. So the driver presses the ACPET, then a throttle valve opens where air enters into the engine. Fuel is injected into the engine, and then there is the turbocharger and then the exhaust. Now, all this is controlled by electronic control unit, and this electronic control unit is called engine control module. Okay. Right. Then another is safety, very important. So there is airbag ECU. It senses the crash from the pressure sensor. It checks if a passenger is seated, and then accordingly it will inform the squib to open the airbags, and the airbags are deployed. Again, there is an electronic control unit, taking care of this entire action. So body control, what happens? What does the body control ECU do? It aids in locking and unlocking of the doors, with a remote control. Yeah. More. Brake control ECU, what does it do? So when the brake signal is applied, it checks what is the speed of the vehicle, and then it applies the brake with ABS or without ABS. Probably you would have heard of ABS, that's anti-locking braking system. Yeah. This is to avoid skidding of the vehicles. Right. Now, I explained you about so many features, but now let's look at how all these features work inside a car. Yeah, I explained you individually, but then if you look at the whole car, let's see how these features work in unison. Yeah. So scenario one, what happens is automatic locking of doors when vehicle speed crosses 20 km/h. This, you would have experienced this when you're driving, when you start to drive your car, and then after 20 km/h, all the doors get locked. Yeah. So the thing is, the locking and unlocking of doors is done by the body control ECU, right? And it is the brake control module ECU, which is sensing the vehicle speed. So how will the body control ECU know about the vehicle speed? Right? One way is to also connect a sensor to body control ECU, a vehicle speed sensor to body control ECU. But then the sensor becomes redundant and the cost also rises, right? Instead, a simple solution is to have a vehicle network wherein the vehicle sensor speed is put on the vehicle network, and that same speed data is read by body control ECU, and then the data is utilized by body control ECU for locking or unlocking the doors. Yeah. Okay. Scenario two, what happens when there is a crash and airbag is deployed? Okay, now there is crash sensor, airbag collects the crash information, and then it deploys the airbag. At the same time, it will put the crash information onto the vehicle network. So The engine control module also reads the crash information that's there on the vehicle network. What it does is it shuts off the fuel injections immediately. Why is it required? In case of an accident, when there is a crash, there might be sparks, and because of the damage, the fuel might leak and it might catch fire. So to stop this, the engine control ECU shuts off fuel injections. Also, there is body control unit. It will receive the crash information and it will unlock all the doors for the passengers to move out of the vehicle easily. Yeah, you see again, vehicle network comes into picture here. You're already seeing the importance of why a vehicle network is required. Okay. So how should the vehicle network be? So what you see in this picture is a point-to-point network. If this happens inside a car, then there are at least 50 to 100 ECUs in a modern car today. And then if you have to connect that point-to-point, then it's just crazy. You'll have a lot of wirings and a lot of weight is added to the vehicle, and it is not good. Yeah. Now, next is a single bus or a multiplexed network, wherein there is one single bus, one single line, and then all the ECUs, the sensors and actuators are connected to this single line. So here the complexity comes down, the cost and weight will come down, but at the same time there is the cons is that only one node can communicate at a given point of time. Yeah, and if the bus breaks, then the communication between the ECUs will also break. All right. So we now established the fact that there is a network needed inside the car. But what should that network be? What are the features of those network? How should it be? These are the questions that will come next. So here are some of the requirements of a network inside the vehicle. It should be low cost, low weight, obviously. Then it should be immune to external noise, to the electromagnetic interferences. And then it should be able to operate in harsh environments because, as you know, automotive, there is a lot of vibrations, there is a lot of EMI. So such harsh environments should be handled. Should be robust and reliable. It should be real-time operation. Yeah, this is an extremely important point here. So we can always argue that we can take a LAN cable and communicate because it works well, but LAN, what we use, is not real-time operation. Yeah? Real-time operation is really important. Then error handling. So when errors occur, then such errors should be handled well. So should be single-lined module should be, we should be easily able to plug in and plug out of the network. That's something which is very important. Then should be multi-master. That means more than one ECU should be able to communicate on the bus, even if not at the same time, but at different times, more than one node should be able to communicate. Yeah? These are some of the very important requirements of a network inside the vehicle. Okay. Some of the early multiplex networks that were available was, what used to happen is before, in the early days, each company had their own kind of network that they came up with when they started using electronics inside the car. So GM came up with variable pulse width modulated network. And then Ford came up with pulse width modulated network. There was Chrysler with collision detection network. Then Peugeot with vehicle area network. BMW called it iBus. And then body electronics area network was brought out by Toyota. What happens is, if you see, each company has their own network, and there were more networks earlier. So each company had their own protocols followed and their own kind of network, which was not good because there was no plug and play possible. ECUs are always like, you have to customize each ECU software for the network, which means there's a lot of extra cost on the suppliers of the ECU. And then reuse was not possible. It was high cost always, and there was no benefit of using a unique network inside the vehicle. Yeah. So popular networks that we have today are CAN, Controller Area Network. Most of you know this. MOST, this is media-oriented network, serial transmission. And then there is LIN, there is FlexRay, there is CAN-FD, also a derivative of CAN with flexible data rate. And there is Automotive Ethernet. Yeah, these are the most famous networks that we can see today. Okay, I will skip this part and directly get to the next session. That's diving into CAN directly instead of going through all the networks. So what's the agenda? Let me skip. So vehicle network history, what happened during the 1970s and 80s? There was a sharp rise in electronics in the automobile field. Yeah, this gave like an opportunity for use of in-vehicle network. And then point-to-point communication was the right option, was not the right option. So they went up with the serial communication, and OEMs came up with their own proprietary networks, and there was a need for standard across the industry. Okay, what happened during 80 to 90? Bosch started the concept of multiplex network with CAN. They presented CAN in 1986 at the SAE Congress, that is the Society of Automotive Engineers Congress. And then CAN became the world's first global industry standard for vehicle networking. Since then, even today and in the future, CAN will be used in almost every vehicle that is being developed. It has become that important. Okay. Yeah. Then on, CAN has taken a dominant place, and then it's there. It's there everywhere. It will remain for a longer time. Okay. So this we have discussed, so I'll skip it. So this is the category where CAN falls in. So it's not a point-to-point network, but it's a multiplexed single bus network. What are CAN nodes? So anything, be it ECU or it's an actuator or sensor, that is called CAN node. Mainly, the name CAN node means an electronic device that receives or sends messages and receives on the network. So what's the CAN bus? So it's the physical layer. So what we have, the standard in the industry is two-line CAN, that is CAN high and CAN low. Most of the times, or almost all the times, CAN high is represented by blue in color and CAN low is represented by green in color. Okay. So each node or each ECU or each sensor actuator is connected to both the lines of the CAN. Okay. Next. So the ends of the CAN bus is, terminated with terminating resistors. Yeah. There is a logic behind this. Yeah. The reason is, if you leave the lines open, then there is an impedance mismatch created between the lines, and because of which any signal sent by an ECU will go and then get rebounded back onto the network, leading to errors on the network. Yeah. To avoid that, a matching terminating resistor is used at the end, which will match the impedance, because of which the signals will not rebound and the errors will not occur. So in case you're trying to use CAN network and if you have errors on it, even though everything you have done is right, everything that you have done is fine, then check if there is a terminating resistor. If there is not, then use one and then the errors will disappear. Okay, until now, what we see in the previous slide is I've shown that the CAN lines are parallel to each other. But in reality, the CAN lines are twisted. Probably you can see this here. We say unshielded twisted pair. So this is a twisted pair of CAN high and CAN low lines. Yeah. The reason why we use twisted pair lines here is because both the lines will carry signals, electrical signals, which means by nature, they will emit electromagnetic waves. Yeah. And if you have parallel lines, so this will emit electromagnetic wave, this also will emit electromagnetic wave, which will create interference to other electronics around CAN lines, which is not good. Yeah. To avoid that, they twist these two lines. So what happens is the twisting is done in such a way, in such an angle that the electromagnetic waves from CAN high and electromagnetic waves from CAN low, they cross each other in such a way that they get cancelled. Yeah. If you want more information how this happens, you go to the thumb rule and study the thumb rule, and then you'll know how the electromagnetic waves are emitted. And then the waves from CAN high and CAN low cancel each other because of the twisting. And that's how the electromagnetic interference emitted from CAN lines is cancelled out. Yeah. Okay, the same thing I'm explaining here. And there is one more important thing, is why are there two lines in the first place, CAN high and CAN low? Can we not achieve it with single line? Well, one of the requirements that I was talking about for an in-vehicle network is that it has to be stable. It should not get affected by electromagnetic interference. So with having two lines, they have achieved that the external noises will not affect the CAN communication. How it happens is, so when you have a single line and then you send out information on a single line and there is electromagnetic interference on that line, then the entire signal gets distorted. Yeah. Instead of 1 volt that you're sending, what reaches the other end of the communication might be 1.5 volts or 2 volts, yeah, because of the interference. Now, when it comes to CAN high and CAN low, how the communication happens is not through direct ones and zeros, but through differential voltage. It's not 0 volts or 5 volts defining logical high and logical low, but a differential logic. Okay. What differential logic means is the difference of the voltages between CAN high and CAN low will define logic high or logic low. Okay. So if there is an electromagnetic interference, which is external and affecting the CAN bus, then it will affect both CAN high and CAN low. So if you send 2.5 volts on CAN high and 1.5 volts on CAN low, the difference is 1 volt. And let's say there was an electromagnetic interference and it will affect both the lines. And instead of 2.5 volts on CAN high, it will send 3 volts. And the same will, the CAN low voltage will also be affected. And instead of 1.5 volts, it will deliver 2 volts. But in the end, when you take the difference between the two, it will still remain the same, 1 volt. 3 minus 2 volts is 1 volt. And 1 volt will be transmitted to the other end. So this is something really nice that they use differential voltage and they are able to work against electromagnetic, external electromagnetic. So that's what I was talking about. The differential voltage, how it works. So CAN high and CAN low. Instead of direct logical 0 volt and logical 5 volts, so we take difference between the CAN line high and CAN line low. Okay. So these are, there are a few terms which you have to remember when you are working with CAN. Logical 1 is termed as recessive, and logical 0 is termed as dominant. Yeah. So when you are working with CAN, and if you're going deeper into CAN, then you'll not say I'm sending 0 or there is a 1 on CAN. You will say there is a dominant or recessive bit on the CAN. Okay. CAN hardware. So an ECU itself, some information about CAN hardware, how it works. So if you look at an ECU itself cannot communicate directly on the CAN bus. The reason is ECU operates at logical levels. It does not operate with differential voltages. So directly whatever the information you have on the ECU, you cannot directly put it on the CAN bus just like that with connecting 2 pins on it. So what is required is, first thing is a CAN controller. Yeah. So what happens, whatever information you have on the ECU will first be given to CAN controller. Now CAN controller will act more like a postman. What it does is it puts your data inside an envelope. What I mean is it will create a message where it will have CAN IDs. So ID represents what is the message name or message identifier. And then there will be other checks like CRC, cyclic redundancy check, and then start of frame, end of frame. Then to control how the entire message is sent, there will be control field. So all these things will be appended to your basic data from the ECU. And this will be done by CAN controller. Now again, CAN controller itself works on logical levels. So even the CAN controller cannot put the data entirely onto the CAN bus directly. What is required is CAN transceiver. The job of CAN transceiver is to take the data that has been formed into a message, into a frame, and then convert that from logical levels to differential levels, and then put those voltages on the CAN lines, CAN high and CAN low. Yeah. And it will also take care of how fast the data has to be converted from logical levels to differential voltages, and it has to be put on the CAN lines. And it will also do the back job, that is converting the received message, received differential voltage into logical levels, and then the same will be provided to the controller. And now controller will collect all the information, the entire CAN frame, decode it, just take the data, and then the ECU will utilize it. Okay. So what is a CAN node? So it is the ECU, the CAN controller, and the CAN transceiver put together will form a CAN node. So the ECU can be replaced with sensor, or it can be replaced with a an actuator. But then the CAN controller and CAN transceiver will always be required for converting the data. Okay. All right. Next, the CAN node software. What about the software? So the ECU provides, like I explained directly, it provides the data. It cannot put it on the CAN bus. So there is CAN controller, which will do the job of taking the data and then forming a CAN frame. And how does the CAN frame look? So this part, what you see here is called the data field. This is 8 bytes in length. So you can either put 0 bytes or you can fill it with all 8 bytes of data. So this piece of field, what you see here, is where our data lies, is what the information from ECU will be put into this field. Apart from this field, this is one single frame, and this entire frame will have start of frame, arbitration field, control field, CRC field, acknowledge field, and end of frame. Okay. Probably you'll never look at this kind of frame in your career, because even when you use CAN tools, you'll not see the CRC field or the start of frame, end of frame, or the acknowledgement field. Yeah. what is important for you when you're sending a CAN message is that you provide data, important, and you say what is the length of the data that goes into the control field. That is, either you can send 0 bytes or you can send 1 byte, 2 byte, 3 byte, up to 8 bytes. So you have to tell here, you have to define the number of bytes here in the control field. And then the arbitration field, what goes into arbitration field is the CAN ID, the identifier of the CAN message that you will be assigning. Yeah. So we'll be having a look at the tool and how we'll be sending the CAN messages later, but I want you to know that these are the 3 important fields. Oops, sorry. Arbitration field or the CAN identifier, the data length, and the data field itself. These are the 3 important fields you'll be looking at. Okay. So there's one important lesson, that is the CAN identifier. Arbitration field is what it is called. Now, if you look at the meaning of arbitration on Google or in a dictionary, it mainly means settling a fight. Okay. So the one question that comes in, which is very important on the CAN, is what happens when 2 CAN nodes try to communicate on the CAN bus at the same time? Who should be allowed to communicate? Yeah, that's a very important question that comes up. This question is answered by setting the CAN ID. Okay, so how the CAN ID, which is smaller in number, in the value of its CAN identifier, that number will have a higher priority. I'll explain you how. So let's say there is ECU1 and ECU2. Both of them are trying to communicate onto the CAN bus at the same time. Okay. Now, like we saw here, the first thing that goes onto the CAN line is starter frame, which is 0, 0. Even ECU1 will put a 0 on the CAN line. ECU2 will also send a 0 on the CAN line. Then starts its arbitration field, like we see here. So we go in, and then it will start sending the CAN identifier. So let's say the ECU1 identifier starts with 0 and ECU2 also starts with 0. The next bit that the ECUs put is 1 and 1. ECU1 will put a 1, 1 again. Now, ECU1 will put a 0, which is nothing but called as dominant bit. And then ECU2 will put a recessive bit on the CAN lines. At this stage, you see that till now, they were putting the same identifier bits onto the CAN lines. But now, at this position, the 4th bit position of the arbitration field, ECU1 puts a 0, ECU2 puts a 1. Okay, 0 is a dominant bit, 1 is a recessive bit. So what goes on the CAN line is the dominant bit. Okay, so if you check the CAN line at this position, it will not be 1, it will be 0, because 0 has a dominant position in CAN. Because of this, you know, when ECU1 and ECU2 are communicating, they'll not only send data on CAN, they'll not only put the bits on CAN, but at the same time, they'll be reading back. Okay, so until this position, whatever bits they had put, they'll read back the same. But when they put bit 0, the dominant bit is put here, and ECU puts a recessive bit, both the ECUs will read a dominant position on the CAN line, which means for ECU1, whatever it is doing is still correct. For ECU2, it has put 1, but it is reading 0 back on the CAN line, which means ECU2 understands that it has lost the arbitration. So ECU2 will stop communicating any further, but it will convert itself to receiving mode instead of transmitting mode. ECU1 has won the arbitration, so it will continue to transmit on the CAN line. This is very important, very, very critical, because when you're designing your CAN network, mainly your signals and messages, so the CAN identifier will define priority. So if there are messages from airbag ECUs which are critical, so such CAN IDs will have a higher priority. That is, it will have a lower value of CAN identifiers. Any CAN messages, let's say from infotainment system, it's not so important. It's not so critical for the operation of vehicle. So such CAN messages will have lower priority. That is a higher value of CAN identifier. Okay. So if you have a doubt, please stop me and you can ask. So that's not a problem. Fine. I'll continue.
Hello.
Yeah.
Yeah. I have one doubt.
Yes, please.
Yeah.
Can you please state your name?
Yeah, myself is Lingam.
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 Lingam. Hi, Lingam.
Yeah.
What do you do?
Yeah, basically we are discussing about this topic, right? Arbitration field.
Yes.
Yeah, ECU1 and ECU2 have a like if, first of all, yeah, ECU1 have 121 message ID. Okay. Now ECU2 have a message ID to 250.
Okay.
Okay. Now
yes.
In this field, which bit is going to be sent? Either is first MSB bit or LSB bit. If it is going to send MSB bit, what will happen? If it is going to send LSB bit is first, what will happen?
Okay.
Yeah.
Yes. Good question. So
Yeah,
what I'm
understand
going
my question?
to do is, yes, give me a moment. I'll make it easy for you.
Okay.
So let me go to a programmer's calculator. So you said, let me take another calculator. So I have two programmers calculator. So let's say ECU1, what was the value that you were telling?
Yeah.
121.
121. Yes.
Okay. What is this one? 250.
Yeah, anything. Okay.
Okay. So now you see in the binary, it's displayed as bits. Okay. Lingam, are you there?
Yeah, there, yes.
Yeah. So you see, we start sending bits one after the other. Okay.
Yes.
And then when arbitration happens, you see there's already a dominant bit.
Yes.
That is, sent. By the way, what we see here is 8 bits only. An identifier can be either 11 bits or it can be either 29 bits. So 11-bit identifier is called, standard.
Yeah.
And 29-bit is extended.
Yes.
Okay. What gets sent in reality is not 8 bits, but 11 bits in size.
Okay.
Yeah.
But my question is here.
Mm-hmm.
Yeah, we are going to sending is first MSB bit right here, 121 and 250. But arbitration process will happen here, 0 and 1. Mm-hmm. ECU1 is going to be win the process, right? Whenever going to send ECU1 and ECU2,
right.
121 is going to send arbitration process. Then win the bus. Yes.
Correct.
Now my question, if you going to send is first LSB bit has to 1, first bit. Okay. 121. Then second time is going to sending as 0. Then at that time also going to win the bus also be 250, right?
Yes, but why do you want to send the LSB first?
Yeah, my question. Why can't you send the LSB bit is first? Why we are going to choosing as the MSB only sending is first?
Well, that's the way we work with it. We send the MSB first. Start of the frame, and then if you look this here, so start of the frame, there's 0, and then comes your arbitration field. So this entire number, what you see here, is in the arbitration field. 0, 1, 1, 1, 1, 0, 0, 1. Okay. So start of frame goes first, and then the MSB goes first, and then the other bits follow. Start of frame, then 0, then 1, 1, 1, 1, 0, 0, 1.
Okay.
See, for you as a human being, what you program is you already put the value 121.
Yes.
Okay. That in binary is represented as 0, 1, 1, 1, 1, 0, 0, 1. Okay.
Yes. Yes. Okay.
For you, it's just this number. So this entire number will go and sit in the arbitration field, actually 11 bits in size. So what gets sent is going to start from the MSB and go towards LSB.
Okay. Means it go to first is MSB bit, right?
MSB, correct.
Okay. Not going to send for LSB.
LSB, no. Only if you want it, then you have to put the ulta of this, starting from so only if you want, you can change it. Otherwise, the controller will follow this number directly. Only if you want, then you have to put 1, 0, 0, 1, 1, 1, 1, 0. In decimal 158 when you go from LSB to MSB.
Okay.
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 So let's go to 11-bit. This will be the value that you will put if you want to do ulta of this.
Yeah.
Yeah.
Thank you.
Yeah, you're welcome.
Hi, Nirmal.
Yeah, hi.
Yeah, my name is Babu. In control field, there is a R0 and a DLC, right?
Correct. Yes.
Yeah. When exactly we are going to use R0?
Wait a moment. That's my next slide, actually. So you want
to... okay. Fine. Then you're going to explain.
Yes. Shall we come back to this later once I finish?
Yeah, sure. Yeah, sure. Nirmal. Thank you.
Thanks. So then, sorry, I haven't seen this. So I might not see your chat, but you can let me know. Like you can stop me and ask me questions if you have. Okay, that was about arbitration. Properties of CAN. The same properties here with CAN, you can prioritize messages like we were discussing right now with the CAN identifier. You can configure your CAN IDs, you can configure your CAN messages. It's multi-master, so it's not one ECU communicating all the time. So any ECU can start communicating at any point of time, given that the bus is free. And then multicast reception. So if one ECU puts data on the CAN lines, all other ECUs can read it. It's not like only one ECU can read it. So that's why it's called multicast reception. Error detection and signaling. So there is a lot of error handling that can be done with CAN. Then there is auto retransmission of corrupted messages. So if for any case, when the node 1 is sending a message and there is corruption in between, so there will be like errors raised on the CAN network, which means ECU 1 has failed to send the message. So it identifies that and it will retransmit the entire corrupted message all over again. Automatic switching off of defective nodes. So if a node goes defective and it will be given numbers, how many errors it has collected. So after 256 errors, then that node will get switched off. So switched off in the sense it will stop communication on the CAN lines. It will neither receive nor send data. It will turn off the CAN communication. But all other nodes will still continue to operate on CAN lines. But only a node which is defective will turn itself off. Okay, it's immune to external noise. We have seen how it is immune to external noise because of two lines and using differential voltage between the two lines, CAN high and CAN low. Okay, supports up to 1 Mbps speed. So you can choose 250 kbps or 500 kbps or 1 Mbps, and it depends on the kind of programming you do on the ECU. Okay, layered architecture. So this is how it looks. I'll not get into it. So if you want, you can always have a look at it later. What is a CAN stack? So there will be ECU developer. He will develop the entire ECU software functionality. And what does a CAN stack developer do? He will provide the CAN. So there is a document called CAN specification. You can search on the internet and you will find the document. The entire content of that CAN specification is implemented into CAN controller. And then the CAN transceiver will only convert the logical data to the differential voltage to be put on the CAN hardware lines. Okay. Now, what does the integrator do? He takes the ECU. He will take the CAN stack, that is the CAN controller and CAN transceiver, and he will integrate these both at the hardware level, as well as there will be a need to interface the software of the CAN even at the software level. Yeah. And then once you integrate, this entire thing will become a CAN node. Okay. One more important thing, how are CAN messages configured inside a vehicle? So what happens is there are a lot of things that you have to do when you are configuring CAN messages. Mainly, you have to decide what is the CAN ID you have to assign to certain messages. Okay. If you look at the entire vehicle, there will be thousands of messages that will be exchanged between the ECUs. In this case, let's say it's not easy for a fresh graduate or a person who has just started to work on CAN to configure CAN messages, or can configure but not to plan what the CAN messages should be, what its identifier should be. Someone who is an architect or someone who is an ECU engineer will be able to do such a thing. So he will decide on all the ECUs. He'll look at all the ECUs in the vehicle, and then he will identify which is more critical, which has to get more priority, and accordingly he will assign the CAN identifiers to the messages. And not only that, the data that you send on the CAN lines, it's in hex format or zeros and ones. Okay, there needs to be conversion done when you want physical data out of it, and such conversion formula, such conversion factor and offset will have to be defined, and that will also be defined by a system engineer. And such a definition will be put into a file called database. Okay, and there will be CAN matrix. It will say which ECU is sending what data and who is receiving that particular CAN message. Okay, the responsibility mainly lies with system engineer. He will have an overview of the entire knowledge of the entire vehicle. Okay, so CAN tools. What are the different? So what happens is, let's say this is your vehicle. There are several ECUs on your vehicle. Now, what if you want to test the messages on this particular CAN line? You know, I was earlier talking about features of the in-vehicle network, and I said one important feature is plug and play capability. So CAN has that capability. So if you just plug into the CAN lines, CAN high and CAN low, and then use a communication interface and connect to your PC, you can read what is going on this CAN line. And that's how you can read data. You can send data to a particular ECU, read data from a particular ECU because you'll know the CAN ID. And that's how you can perform testing of the entire vehicle. Okay, so simple database, how it will look. So if you look at this, the CAN message ID is 0x34. Okay, and there will be 8 bytes inside it. So sometimes you might not use all 8 bytes for a single data that you're sending. Let's say if you're sending engine speed, you might only use 1 byte of data, or vehicle speed for 1 by 2 bytes of data. Yeah. So you can divide one CAN message itself into several signals, and you can define those signals. You can say which byte and what is the length of length that will be used by engine speed, what is the length that will be used by vehicle speed or coolant temperature, and which byte they are assigned to. And you will also define what is its minimum value, what will be its offset, what will be its scaling factor. Yeah. Okay. So that's CAN matrix. It simply says which CAN ID, who is the sender, and who is the receiver. Yeah. This is very simple. Okay. Any questions till now? All right. Great.
Hello.
Yeah.
Sir, I have one question, sir.
Yes, please go ahead.
Sir, in a CAN line, we are using a termination register of 120 ohm. So why it is 120 ohm, not at the 119 or 121?
Yeah. So how they decided this was, it's a generic number that we have taken. Mainly, what happened was they looked at a vehicle, medium-sized vehicle, and they calculated the length of the cable that may be used to connect all the ECUs on the vehicle. And then they found out its impedance that came to around 120 ohms. Okay. So it's a generic value that the industry uses. So even if you use 119 ohms, 121 ohms, 125 ohms, it will still work. The value has to be around 120 ohms. It's not like it's a fixed value. It's a magical number coming from somewhere. It's that 120 ohms what we are talking about. It's the value to match the impedance of the CAN lines that we are using. Okay. It's not a magical number, just a calculation and just a generic number that we are using. Mainly this number came because they calculated the impedance of the length of the cable that is required to connect all the ECUs in a vehicle. Okay.
Okay, sir. Thank you.
Yeah, my pleasure. So
hi, Nirmal?
Yes. Hi.
Hi, myself Murli, and I
hi.
just wanted to ask regarding the CAN FD protocol. You mentioned that it's kind of a different protocol in itself.
Right.
But isn't that like an extended version of CAN, or?
Yes, exactly. What CAN FD is, probably I have a picture here, so I'll directly explain. Oops, sorry. So I can directly explain you what it is. Let me reserve this. Get back here. So if you're looking at this picture, if you look at the data field here, I said CAN can carry 8 bytes of data. Okay. In CAN FD, you can carry 64 bytes of data in place of 8 bytes. Okay, that's one difference between CAN, normal CAN frame, and CAN FD frame. Okay, the letters F and D, they means flexible data rate. Okay, what happens is, if you look at CAN and if you say its baud rate is 1 Mbps, so from the start of frame bit to the end of frame bit, every bit is sent at the same baud rate. Okay, 1 Mbps. Now what happens when you are doing arbitration field or control field or CRC checking? The process has to be slower because you have to logically check if the CAN identifier is right, or if the length of the data field is right, or if the checksum has to be calculated. So it takes a longer time. But when you're sending the data, you're just sending the data. The CAN processor or the CAN controller need not do any logical calculations. It only has to collect the data and put it into a buffer. Okay. Yeah. So what happens when they introduced CAN FD, how they planned is that during start of the frame till end of control field, the data rate, it will be one particular data rate. And when you're sending data itself, you can send it fast because there is no logical processing need to be done on the data field by the CAN controller. So until the end of control field, the data rate is different. And then once the data field starts, the data rate is much faster. That's why it's called flexible data rate. Once the data field gets over, again, the data rate that is transmitted gets lower because the CRC field has to be calculated. So in the classic CAN, the data rate that you see is just one single data rate. But if you measure the data rate on CAN FD, so there'll be one particular data rate, and then there is a faster data rate, and then again it gets lower. And the data field itself, which was 8 bytes earlier, is now 64 bytes in size. Okay, because you can send data much faster. So in the end, what they have achieved is, compared to maximum 1 Mbps of speed on classical CAN, you can achieve 8 Mbps or even 10 Mbps on CAN FD. Okay. It won't be 10 Mbps all the time. It will be 10 Mbps only when they're sending data, the data field is getting transmitted.
Okay, so does this mean we have to have a separate transceiver for processing the CAN FD, or can the standard CAN and the CAN FD coexist on a single bus?
It can coexist on a single bus, but if you're only looking at CAN FD, you'll need a new transceiver. You'll also need a new CAN controller. So CAN FD can perform classical CAN, but a classical CAN controller cannot perform CAN FD because it's only set to a single data rate. Yeah, got it. But CAN FD is like back compatible.
Okay. Yeah. Thanks.
All that the CAN FD controller has to do is slow itself so that it matches with classical CAN.
Yeah.
All right. Thanks for the question, Murali. Okay. Now, the important thing is, Bhishma, I think I have less than 10 minutes. Do I get a little more time, or should I get to some important point?
Yes, Nisarg, you can.
Okay. Then what I'll do is I'll go a little fast. I'll only discuss the most important points. So if you look at CAN frames, there are mainly 4 different types of frames. That is data frame that will carry data. Remote frame, this is like a request for data. So one ECU will request another ECU to send a particular data. So a remote frame will not carry any data. And then there is error frame sent by any of the node to signal other nodes that there is an error on the CAN network. So the node should stop transmission. Then there's overload frame. What happens in overload frame is let's say ECU1 is transmitting a lot of data continuously and ECU2 is receiving. So ECU1 is putting lots and lots of data on the CAN lines, but ECU2's buffer gets loaded. So it is not able to process the data as fast as ECU1 is sending it. Okay. In such a case, ECU2 wants to tell ECU1 to hold on for some time. So at that time, ECU2 will put an overload frame on the CAN network. So ECU1 will identify it and it will stop sending any further messages just for a few milliseconds, so that ECU2 gets a chance to process all the data that it has already buffered. And then once it is done, so ECU1 can again send all the data. So that's overload frame. How will a data frame look? So this is how a data frame will look. I'm not sure why this is not going away. Okay. So what I'll do is, it's a lot of explanation to do and I have very little time. So I'll get to the question of the control field. So here is the control field. I'm sorry, you wanted to ask when is R0 used, right?
Yes, Nirmal.
Yeah. So data length is these 4 bytes, and you know this defines already what is the data length, 0 to 8 bytes. R0 is reserved. It's not being used at the moment. Okay. But R1 or IDE is used. IDE is identifier extension. It will be used when you have a 29-bit identifier instead of 11-bit identifier. Okay. You don't have to worry about this because probably you'll never get into the depths of each bit or each field of a CAN message. What is important for you is how you'll use CAN message to communicate. Okay. Probably, I'm sorry, I'll not go further with this, but instead go ahead and show you how to send and receive CAN data using tools. Okay.
Oh, okay.
So what I'm doing here is setting up all right. So what I'm showing here is a tool called CANeasy. So CANeasy is a CAN data analysis tool where you can send data and to ECUs over CAN lines and also receive data from the ECU, record it, analyze it, log it. You can do a lot of things. So what is important is we were talking about a CAN database. So if you have a CAN database, for example, which is called DBC, okay, you can directly drag it and drop it here. So I'll say, okay. So my CAN database gets imported. So interesting part is you can look at a CAN database now. For example, if I go to motor 1 and click on current speed here, what you see here is definitely—
Is this open source, Nirmal? Is this open source? So is there any soft? Yeah.
Yeah, this is not open source, but it's a paid software. So if you're
Is
looking
there
for
any open source for CAN controller to
yes,
verify the CAN? Yeah.
right.
May I know that?
Yeah,
May I know
you
the
can
name?
use Busmaster from Robert Bosch.
Okay, okay.
That's an open source, but then it's limited in its operation. This, what you see, CANeasy is also, there is one version called Basic, which is free to use. Okay. But when you want more features on CANeasy, then you will have to buy it. But this free version of CANeasy, it's called CANeasy Basic. You can already use it for communication on with the ECUs.
Okay.
You can import database file and you can communicate, you can log data, you can do a lot of things on it.
Even though CAN OE also, we are going to use 2 CAN signals, right, for basic trial version.
So if you want a trial version, we can provide you a trial version, but which is limited by time. And with CAN Easy, you can communicate up to 99 different CAN channels.
Okay.
Yeah, but
okay.
The basic one, which they give it as free, it's limited to one channel only.
Yeah, fine,
So
fine.
If you want to try it out, then we'll give you a trial version, which is full professional version, and it will be limited by time by like 30 days or 60 days.
Yeah, please share, Nirmal. I will see on it.
Sure. Sorry, I did not get your name. What you can do is probably you can write me an email.
Yeah, sure, Nirmal. I have your mail and contact number. I will contact
Sure.
you. Thank you.
Wonderful. Thanks. Okay, we'll get to this at the last. So what I'm trying to show is how you communicate with CAN, actually. Yeah. Very important when you're using CAN is like the database. What if you do not have database? If you simply connect to the network, and if you look at the trace panel, yeah, all that you can see without a CAN database is these hex data. Absolutely nothing. You can make out nothing. It's just 8 bytes of data field that you will see. And also what you can see is identifiers, but then you will not understand anything. Yeah. If you want to put meaning to this data, this hex data that is going on here, you'll need a CAN database. Yeah. If you want a CAN database, it's proprietary information. No OEMs will provide it to you. But if you're working in the industry and then if your company has the CAN database, drag and drop it here, it will get read and then it will show you all the information. Motor 1, for example, is a message. You can see it here. So that motor 1 is also, being sent here on the trace, what you see here. And these are the 8 different data fields. There's the entire data field and 8 different bytes. Again, what you see here inside is hex value. But from the CAN database, I know that there is current speed and RPM. That's what you're seeing here. Okay. And if you still want to view it in a nice window, you can make a new signal monitor. Just drag and drop it on the new monitor. Also the RPM. And then double click and then you view it in a bigger window. And if you want to plot it, you also want you're already seeing it as numbers. What if you want to see it as signals? So go to signal plot, add a new plot, simple again, drag it and drop it. Drag all the signals that you want to view and drop it and double click. You will have these signals scaled according to the size of your window. Okay. And let's say you do not want overlapping, then you can view 2 different signals here. Okay. What you're seeing here is already the physical value. Okay. This data here inside these bytes, 8 bytes of the data field is hex value, and that is converted into the physical value and displayed for our viewing. The information that is needed to convert the hex value into physical value, or this hex value is also called as raw value on the CAN. That detail is available in the CAN database. Without the CAN database, we'll never be able to convert and view the physical value. Let's say you want to send a new message out. So what you can do is, with this tool, is just right click and then you can add a variable. Sorry. Let me remove this. Yes. So right click and then I can add a new control unit. Under the control unit, I can define a new message. And then there you go. I have my message ready. to be sent. So I can add values into it. And then I can click send. So if I open my trace, and then I click on send, it gets sent on the trace. So it's now very difficult to search. So all I have to do is type in here and okay. Okay, it will not search because this particular message is not defined in the database file.
Hello.
Yeah. Hi.
So how is it different from, you are using CanEasy, right? So how is it different from Cano? So also we can add databases and we can check through trace, right?
So you just want to know how it is different from Cano?
Yeah.
Okay. See, Cano is also a similar tool, which is mainly the purpose is to record or view or analyze CAN data. Okay. So if you look at Cano, Cano is limited in reading few CAN channels, but CanEasy can read up to 99 different CAN channels at the same time. Okay, and here you drag and drop a CAN database, and simply you get it. What you can also do is you can have rich panels. Yeah.
Okay.
So it's so simple to create rich panels. I'll show you. So I'll put edit. What is rich panel is you're seeing RPM and current speed here in numbers. Okay. What if you want to represent it with, let's say, a nice gauge? Yeah. You come to panel editor. So go on the left-hand side, you have a lot of options. So I'll bring in a nice gauge here. Okay. And then I'll go to my database. I want my current speed. I'll drag it and drop it. Okay. Now my rich panel is ready. I will save it. Okay. Just double click it. Run it. Do you see? I already got my rich panel running here. Mainly the flexibility of usage and how quickly you can set up and how nicely you can use data. So I'll show you the signal plot, and let me go to signal monitor and yes. So I'm representing the current speed here. So according to the speed, the numbers that I see, I'll seeing it on the gauge. Yeah. This was just an example. I took less than a minute to create this, but if you spend time, you can create nice, rich panels on this very quickly. It's very simple to use, only with drag and drop functionality.
Yeah, one question. Will it support CAPL also?
Yes, it supports CAPL. You can import CAPL, even if you have an entire Cano panel that you've already designed on Cano but want to use on CanEasy. Just import it, load the panel here. The entire CAN panel will get loaded. Right now, I do not have a CAN panel. So all you have to do is just search for it on your laptop and then import it. So the entire Cano panel will be imported. Yes, you can also import CAPL code. And if you want to script, you can also script using Python. You can script using C#.
Okay.
Yeah. So you see here, CAPL, you can load your application or you can create your own application. It will open the Visual Studio Code. Visual Studio Code is now an open source for editing. It's an IDE for editing your scripts. So either you can choose C# or Python, and whatever you script here will get loaded onto CanEasy. So thereby you can, automate your entire processes. Okay. So what more I can show you is, so if you have your trace panel and you have loaded your, hello?
Nirmal, Manjunath here. So does it also support ODX and the ARXML formats database?
Yes, it supports ODX and, okay. Okay, then I'll just give you the entire feature list of CANeasy. Give me just a moment so you can have a look. So here are the features. Number of buses, you can go with 99. So it supports CAN-FD, it supports LIN, and it supports Automotive Ethernet when you're going with the complete professional version. Supports XCP, SUM, IP, DOI, PODS, 1939. You can play back the recorded or logged data. There's a trigger, you can schedule it, you can do macro recorder. Trace window, you already saw. Signal plots, you have already seen. So you can edit the database, and you have the DBC, ARXML, LDF. Yeah, somebody has a question? Sorry.
And how about the hardware interface? So there is some hardware interface available from CANeasy, or we can reuse the vector ones or the one?
Yeah, this is one advantage with CANeasy, is that it's not limited to a particular hardware. So it's open software for communication interfaces, which means you can use hardware from Quasar, from Vector, from Intrepid, Peak, ETAS, Softing. So these standard communication interfaces, if you already have, you just plug it in. So that is something probably I did not show you. If you go to the hardware, all you have to do is, when you install the device driver of your hardware, it will automatically appear here. So you just have to refresh, and it will try to read all the interfaces or device drivers, and it will show up here. So right now I haven't connected anything, so it will not show anything. So you can import ODX, CDD, PDX, record it in even MDF format for analysis, or just text format, and lots and lots of features. Also, you can have MATLAB and Simulink plugins, external API. So like you say, like someone asked, CAPL converter and CAPL loader, rich panels. These are the features of CANeasy. That's what you see here.
Yeah, thanks.
My pleasure. So any more questions? Anything else you want to know? So what I showed you was, I think it was very quick for a fresher to learn the last few parts. But if you want to connect to an ECU over CAN and read data, you will be able to directly read hex data, what you saw here on the trace window. And if you want a meaningful display of hex data, like the physical values, for that, you will need a database file. And the database file, you have to ask your manager or your lead to provide the database file. So once you have it, it can be converted and you get meaningful values on your CAN tool. Okay. Something that I missed out was diagnostics. So to do diagnostics, you will require one small slide. I'll show only few pages because I think I've already overshot with time. one very important information what I'd like to show is this. So what you see here is a CAN frame, and what is diagnostics is, diagnostics is done over CAN or any other vehicle network. So for now, I'll take CAN as an example. You send a request to the vehicle over the CAN network. So your request will actually reach the ECU over the CAN network, and the ECU will identify what your request is, and the response will be sent. And you can read it on your screen. So your request can be to read the vehicle speed or the engine speed or some other data from the engine, probably a sensor value or a fault that has happened on the vehicle. Anything can be read out, but provided that there is a way you have to send the request, and then there will be a way the response will be sent. Now, these ways, how you have to send a request and how you have to read a response is all defined inside protocol. And such diagnostic protocols will be defined. The main ones used in automotive field is called UDS, Unified Diagnostic Services. The standard is ISO 14229. And apart from the UDS, there are also standards like J1979, J1939. These are mainly used by government authorities for emission controls. Okay, they define what data has to be read from the vehicle, and every vehicle has to give that data out. But using UDS, OEMs can do their own specific testing of the vehicle. And that entire protocol is, again, a very huge topic to talk about. There's a lot of things. But what you have to remember is, using CAN messages, diagnostics will be performed. How? Starter frame, arbitration, control field, everything is done. Within the data field, the 8 bytes of data. So service ID, a service is nothing but a request, for example. It will have an identifier, a sub-function, and the required parameters. Within those 8 bytes will be sent to the vehicle, and the vehicle will respond back on a CAN message within that 8 bytes of data, and the same data will be read by us. Yeah. For all this, we must follow the protocol. If not, there will be no response from the ECU. Okay. I don't know. I think it's not a good idea to extend the time more. Bhishma, probably I can have another session on another day for diagnostics. Is it okay that I stop it here?
Yes, Nisarg. Sounds good.
All right. And I'm very sorry to others. I overshot for another 17 minutes, but I hope I was able to deliver some learnings to you, especially the new one, the fresh engineers.
Yeah, Nirmal.
Thank you. Thank you. So if you have more questions, you can write to me or you can contact me to discuss about it. Bhishma, probably you can make my email available to them so that they can write to me.
Sure, Nisarg. We will do that.
Sure.
In the chat box also, you can type your email ID.
Yeah, that's actually a good option. So that's
Thank
my
you,
email
Nirmal.
address.
Actually, good session, but we thought it may be a complete diagnosis
I
also.
would love to do it, but I don't know. I mean, I've overshot. It's a huge topic, actually. So
yes, Nirmal.
We need more time.
Yeah, maybe you may take another 2 hours also. It may be that much huge topic. I know that.
Correct.
In a DCM and a DEM, there's also a huge topics.
Yes.
But what I am exactly required in this session is how we are going to develop using a C or Python. That is my I come to here in this session, but will not come to that part actually. Yeah.
Sorry, but I had to look at the fresh engineers also, and to accommodate the experienced one also with the tool. So probably
good session, Nirmal. I will write a mail. Yeah.
Sure.
Thank you so much. Yeah.
Thank you very much. Thank you all. Thanks for the participation.
Thank you, Nirmal. Thank you so much.
So Dear participants, I will take you 2 minutes of your time to read the vote of thanks. So on behalf of ANCIT, let me call it as an automotive fraternity hereafter. And on my own behalf, I extend a very heartfelt vote of thanks to all the speakers for gracing this conference. Automotive Virtual Tech Day Edition 2 2022, held on 9th April 2022. So to start with, I like to express our sincere thanks to Alessandro, Troisi, Daniele, Marino, and Max Vizzini from ST Microelectronics for giving an excellent coverage in Introduction to AutoDevKit. And I must mention our deep sense of appreciation to Mr. Rinat Asmus, Chairperson AUTOSAR, for his explanation on AUTOSAR and its future. And I also wish my gratitude to Eswaraiah from FAIR for his wonderful session on cybersecurity on AUTOSAR. And further, I am grateful to Mr.Srikanth and Kumar from Elektrobit for demonstrating the EB Tresos tool. Finally, we should thank Nisarg for his wonderful coverage on the topic, deep dive into CAN and Diag. Even he is not able to complete today, he will complete us in another session, which is supposed to happen in another 3 months. I thank once again all the participants in the event for the active participation throughout the event. Thanks all, and we will meet in another wonderful session in next quarter. Thanks again from ANCIT.
Yeah, hi speaker. Can I have these videos?
Yeah, it will be. Yeah, it will be uploaded in YouTube in our ANCIT channel shortly after curating this.
Yeah, sure. Thank you so much. Thank you for a session, conducting this session. Thank you so much.
Thank you all. Thanks all. Bye.
Bhishma, also thank you very much for doing this session, a wonderful initiative. So it's a knowledge sharing session that we are able to share knowledge, and for others that they are able to gain knowledge. So wonderful initiative, and kudos to you. Please continue to do this good job.
Thanks, Nisarg.
Also, please keep us connected.
Sure.
All right. Thank you so much.
Good evening.
Have a
Bye
wonderful
all. Bye all.
Bye.
Thank you. Bye.